of artificial intelligence at IIT Delhi, and his expertise lies in remote sensing, multi-temporal image analysis, unsupervised representation learning, understanding of evolution of meteorological variables and land surfaces, and uncertainty quantification. So today he is going to present a keynote on adapting vision foundation models for Earth observation. So with one round of applause, please welcome the keynote speaker, Professor Sridhar.
Thank you for the Thank you for the introduction. So I right now feel like armed for in a battle or something. Today I'll be talking on adapting vision foundation models for Earth observation, as in the previous keynote by Professor Pal, he mentioned that we should not just jump topics, right? So similarly, in my talk, instead of jumping topics, we will take it step by step. So first of all, we have to understand the evolution in the computer vision algorithms. Then only we can understand, okay, like what are these foundation models, or more specifically vision foundation models, because there are the other language foundation models, which I'm not going to talk so much. And then only I will come to the specific cases of the adaptation, particular adaptation for some applications. So this seems to be set up. Is this needed? Oh, let me try it. Yeah. Okay. So in the previous presentation, again, like we saw a few example CNN networks and all, right? So what we are seeing here in the screen is an example of the LeNet 5. Okay. Anyone knows when was it proposed? Any guess? No guess from the audience. Okay, let me just give you blocks. Like, was it presented between 1990 to 2000, between 1980 to 1990, between 2000 to 2010, 2010 to 2020? Someone would like to guess something? Okay, somehow no one is guessing anything. So let me just go on. So it was proposed in 1998, if I remember correctly. It might be 99 also, doesn't matter so much. And is considered generally as one of the fast proper convolutional neural network. Okay, and as you can see, I mean, this was proposed for the character recognition, and in this particular case, we called it LeNet 5 because it had 5 layers in total. Out of that, only 2. I mean, right now people doesn't even count the fully connected layers as such in a count of the layers in a network. So the number of convolution layers were only 2. Okay, not more than that. So only 2 convolutional layers, some fully connected layers. That's why it got the name LeNet 5. Okay, which in the terms of 2025, the kind of gigantic networks that people works with, it's very, very small actually. Okay, then came the 2000s. Okay, the entire 2000s, and the people who were active in the research at that point of time. I was still in my schools and all, and actually started my BTech sometime in the 2000s. But the others, my seniors here who were already active in the research, they would know that at that point of time, Rather than using the neural networks, it was more common to use some feature extraction and then support vector machine, right? So that's what continued for the entire 2000s. Then came 2010, okay, and came this ImageNet challenge, okay. And in the 2010 version of this ImageNet challenge, so what is special about the ImageNet challenge? Anyone would like to guess anything? Come on, I want interactive audience. So what, in the previous presentations, it was already mentioned to you that, right, that for training neural networks and all, we need a lot of data, okay? So we need, not just lot of data, we also need, on the other hand, compatible GPU technology, okay? So some progress in the GPU technology happened in the 2000s. I will not go into that. But also, in addition to that, this ImageNet challenge, this for the first time gave us the opportunity of a humongous data set, okay? So which people can actually use to, like train something. But in the 2010 version, the first version of this ImageNet challenge, what you still see is that all the three winners, the first one, second one, both of them are SVM based. The third one, it's also not neural network based. I don't remember exactly what this is, but it's also not neural network based, okay? There is no neural network, okay, yet. I'm not saying neural network did not exist. This of course existed, like LeNet 5, I told you already, it was already proposed in 1998. But 2010 challenge, humongous data set is there, but people are still not using. They did not got that, like they did not got to that point that, okay, let's use neural network, okay. Then the AlexNet was proposed, okay. AlexNet was proposed when? AlexNet was proposed the next year, 2011, okay. It owned the ImageNet, the same data set, with some modification. They like had the same challenge again in 2011, and AlexNet was proposed, and AlexNet owned it. AlexNet, a convolutional neural network, owned this challenge, ImageNet challenge, in 2011, and from there on, there has been nothing but, like in the image processing domain, I'm talking about convolutional neural network, until something happens, okay? I'm coming to there in a few minutes, in 10 to 15 minutes, but let me stick to convolutional neural network for a while. So the AlexNet that you see here in the screen, it's not the full picture, okay? You are taking, so if I take you back again, one of the first thing that we will observe is that the LeNet, the input, what was the input size? 32 cross 32, okay? AlexNet is already taking the input of 224 cross 224 into 3, okay? Into 3 channel images, okay? Of course, you can make minor modification, you can take more or less number of channels as well, but already 3 channel images, 224 cross 224 size images, okay?
The channel is RGB?
RGB, yeah. So from this, you are applying some convolutional filters, you are getting features of 55 cross 55 cross 48. On the top of this, you are applying some more convolutional filters, you are getting features of 27 cross 27 cross 128, and so on, okay? So this, one of the things that you'd have to understand, that at that point of time also, there were a lot of limitations in the GPU technology, still existed GPU. So the architecture of AlexNet, they had to do a lot of engineering in the AlexNet architecture at that point of time. Like they divided into 2 distinct parts, as we see in the previous slide, so that they can feed this architecture, networks architecture, into 2 GPUs rather than a single GPU. Okay. So these are the rest of the layers. Okay. So we see some more convolutional layers, and then some fully connected layers, and so on. And I don't have the exact calculation, but if you compute the number of parameters and all in the AlexNet, this was much higher already than the LeNet. Okay. So this is AlexNet for you, and the jump is from 1998 or 99 to 2011. Yeah. So what happened in between this time? Are you with me? What happened in between this time? Two major things: the improvement in the GPU technology, right? And also the availability of the data set. If you don't have the data set, okay, there is no point in training like neural networks. So this is there. So this is the, I already talked about AlexNet had 5 convolutional, 3 fully connected layers, and some more details. Let's not go into those. And AlexNet further used some other techniques like dropout, ReLU, max pooling. So these are like, at this point in time, like anyone who works with the CNN, you all know this, right? But AlexNet was the first one to actually use those things. Previous version, the LeNet, did not have them. AlexNet also advocated for the extensive data augmentation as a way to reduce overfitting. So you have an amount of data, but you want more data, okay? So to train neural network, which are data hungry, you want more data. So what you can do is that you can do data augmentation, okay? Simple data augmentation can be just, okay, you just rotate the image or something like that. So, and you can create more data. So this is also a practice that has since then become a normal practice. So now I will take a jump of again like another 2 or 3 years, okay? So VGGNet. So VGGNet was proposed in 2014 by, if I remember well, by a famous group in the UK, by the group of the GSAR man, okay? So he was kind of like father of computer vision kind of guy. And they promote some modifications, okay, to use 3x3 convolutional filter, maintain a consistent convolution filter across all the layers and all, but these are, you know, like probably not so much of interest to you. You have to understand they are making, you know, like at this point, the changes that they're doing is more like an engineering kind of changes, okay? So I will show you a couple of more networks as well, and most of the changes that you will see are more like engineering kind of changes. So VGGNet for you, okay? So what VGGNet at this point of time they promote is that make the network go more and more deeper, okay? So if you put the AlexNet and the VGGNet side by side, you will see VGGNet already is like even more deeper than the AlexNet. LeNet, AlexNet was much more deeper. VGGNet is even more deeper. Okay. So yeah, this is I was talking about that VGGNet has more layers and a large number of parameters compared to the previous model. And around the same time, another architecture that was proposed by Google is the GoogleNet. Okay. So what they say is that this is inspired by the intuition of the multi-scale processing. So from the VGGNet, you remember the filters, the convolution filters that we are using is the size 3x3, right? VGGNet says that we will not use a consistent size filter in a layer. Rather, we will use different size filters in the same layer, okay? So same input gets processed also through the 1x1 convolution, 3x3 convolution, 5x5 convolution, and those outputs get concatenated. And we stack this kind of layers on the top of, one on the top of the other, okay? So this is the inception module proposed in the GoogleNet. It's also 2014, if I remember well, okay? So, the question that we'll ask ourselves at this point of time. So what I said, let's take a step back and recall again that the primary idea of the convolutional neural network, the working version LeNet 5 was already there in 1998. However, to make it, the issues with making it deeper was that, okay, like first of all, GPU technology, secondly, you also need like a data set to scale with, right? So these things came in the 2000s, let's say. Then with the ImageNet challenge, we have AlexNet, we had VGGNet, we had GoogleNet, and there might be some other networks also which people have not remembered anymore. And all of this works, they advocated, okay, let's go deeper, right? But the question that arises is that just going deeper, is this beneficial always? Will we be able to like just improve performance So in the terms of the accuracy or whatever other performance indicator is there, will you be able to improve that just by going deeper?
Not just by going deeper, but number of hidden layers, if we are increasing with change in activation functions, then it might improve the accuracy.
Okay, so what you are saying is more like in the direction of the regularization? Okay, so Professor Sani is saying, okay, if we add some regularization and all, that's true, okay, that I don't deny. However, if the other parameters are the same, so do we expect that the performance gets better with like, let's say, like the more when you go deeper? And the answer that we find is that no. Okay, so we find that a 56-layer network ends up performing worse than a 20-layer network. Okay, and this is not something was expected. I mean, if you're a layman, you think that, okay, let me just add more layers, other things remaining constant. Okay, the regularization and all used to be the same, and maybe the performance improves. But when it doesn't happen, then you will sit back and you will say, okay, this thing doesn't work. You will start complaining, right? So there tools, not to a full solution I will say, but to some extent working solution was provided by the something called ResNet, residual network. They provided something called residual block. Okay, so in the previous presentation itself, the vanishing gradient word was mentioned. So this is one of the problems. There are other issues as well. Why the performance is not just improving with, like adding more number of layers. And this residual block, they said, okay, I will have input, I will have some layers processing it, okay, and I will add back the input, like a kind of identity addition, okay, and I will progress in this way. So in this simple trick ended up showing that, okay, this performance drop that we showed previously, that can be contained to reasonable extent. It cannot be like fully contained, but it can be contained till reasonable extent. This was one major, in my opinion, progress made after the AlexNet. So I think residual block, this was proposed in early 2016, if I remember well. Yeah, and by this time, okay, they are showing, so this is 2015 actually, not 2016. They are showing that 34-layer networks is actually now performing better than the 18-layer network. So earlier you saw that this was actually getting flipped, the performance. Now they are able to show that, okay, like the performance is getting better with adding actually more layers. Okay, but as I will at this point I will take a bit of pause and let me just clearly say this, that the ResNet solution was not something, I mean, it works to some degree. It's not like a foolproof solution. Okay, this is something we need to keep in mind. So now let us jump to the, so we were talking about the convolutional neural network. Now let us jump to the next level. Okay, so now we'll be talking about the transformers. Okay, so the first question that we'll be asking ourselves, like, where the transformers comes into story at all. Like, my story started with the images and the convolutional neural network, right? Transformer, how does it make an entry in this story? So the first I mean, the most important reason why the transformer is making entry is because of the scaling problem that I just described to you in the last few minutes. That if I'm adding more number of layers, or not just adding more number of layers, let's say, like, if I have more training data, does it always mean that just having more training data I will get better performance? With the previous CNN like networks, it was not happening. Okay, so this is basically like, okay, so let's say I run a company A, which has like 1 million turnover, and Sanib runs a company B which has 10 million turnover. So Sanib says that, okay, I am richer than you, I can procure more data, I can put more people into labeling, fetching data, fetching images, labeling them and making the annotation and all. So Sanib makes a claim that, okay, since I am more richer, I can put more people to annotate and make a larger data set than you. I hope to get a like better performance. But that was not happening with the CNNs up after a certain scale. I'm not saying it was not happening at all. 1000 image was probably better than 100 images, but at some point the saturation was reaching, and the saturation, this saturation people wanted to avoid, okay? Both in the terms of this data set size, also in the terms of adding more layers, this kind of. So this scaling is one very important factor. Then the next important factor where the transformer comes into question is the contextual information. So we are talking about the image, right? So when we are talking about the image, given a like a, let's say 224 cross 224 image, even if it's a classification task, there are different tasks that we deal in the image processing. So classification tasks mean given a 224 cross 224 image, you just want to assign one single label. So if we take a picture here, we will say that, okay, this is a classroom, one single label. But we also often deal with the semantic segmentation. So how semantic segmentation is different, instead of giving one single label, we will like to give label to each pixel in this 224 cross 224 image, okay? So we'll be saying that, okay, this is this pixel belongs to a chair, this pixel belongs to a person, and whatever other things are there. So then there is object detection, the example that was already shown, like the bounding box kind of output that was already shown in the previous presentation, right? So these different kind of tasks exist in the image analysis. However, in all of these tasks, the contextual information is very important, because this particular pixel is just black in color, okay? If I just take this particular pixel and give to you that one pixel, take it. Will you be able to tell me what this is? Never, right? You don't have the context. This black pixel could have come from anything. When I give you the entire picture, then you say that, okay, this black pixel, this particular pixel is coming from a screen, right, in a classroom, right? When you have the entire picture, when you have this entire understanding, only then you are able to tell. So this global contextual information, this CNN was not so good in capturing this. CNN with these filters, like let's say 3x3 or 5x5, sliding over the image, okay? Of course, you have the multiple layers, so you could see in effect, when you go through the more layers, you are not just seeing 3x3 pixels, you are seeing a larger receptive field. But that larger receptive field was generally not going to be the entire image, okay? So that was an issue with the CNNs, where also transformer plays a role. So this transformer and the main technique that they involved is the self-attention. I will not go into the details of this. So a transformer encoder, how it works is that like you have the inputs, some of these multi-headed self-attention layers and some other layers, okay, at a norm position wise, feed forward and all. But at this point of time, we need to understand that these transformers I'm talking about, they were not proposed. So the LeNet, I can say that LeNet and all, AlexNet, they were proposed in the context of the image processing. LeNet was proposed for the character recognition, right? AlexNet was proposed in the context of the ImageNet challenge. So this ImageNet, a huge image dataset was proposed, and this guys, they thought that the entire motivation at that point of time was not to, like change the history of the humankind. For them, it was just to win the challenge. There is a challenge, okay, why not win the challenge? That was the motivation. They fought for it, they won it, and it changed everything, right? Transformer, this was not proposed for the image analysis, okay? Transformer was already proposed, if I remember well, 2017, but in the context of the language processing, okay, text processing. What it does is that it processes a sequence, okay? It processes a sequence. We, the image guys, we did not touch it, more or less did not touch it till 2020 or even late 2020, not even early 2020 I'm talking about. We did not touch it. Why didn't we touch it? Okay, we were still very happy with CNNs. The main one of the main challenge I mean, that comes in the mind is that I'm saying that transformers, they were proposed in the context of sequence processing, right? The natural language, which is sequence. So image, given a single image I'm talking about, I'm not talking about a video or something like that, just a single image I'm talking about. How can you represent a single image as a sequence? Can you? Any idea? Different band as different, okay, as that can
Get from matrix to vectors.
from metrics to vectors, okay.
Single line, element system array.
Exactly. Yeah. So we what end? So of course, different bands and all could be also some kind of sequence. I don't deny that. However, the sequence that then in the 2020, the people working in the image processing domain, we ended up coming up with is, okay, this is your image. Why not just take like this kind of sequence? Okay. So this at beginning, I mean, seems like something probably will not even work. Even when I heard it first time, I thought like, okay, why should it work? I mean, this doesn't seem normal. So, but this ended up working very well. Okay, divide the input image into patches, treat each patch as sequence. Okay, one element in the sequence basically. Okay. You can basically take these patches and treat them as embeddings, or you can even take like a do a like a kind of like CNN transformer kind of, because we image process guys, we have been working with the CNNs at that point so long, like 1 decade, so we could not of course give up on the CNNs totally. So why not just like first take a CNN feature extractor, okay, and use those features, extracted features for each patch, and then feed it to the transformer. So this is how we work. And then there are like some minor details like sense of location in the terms of the positional embedding and all. So then basically, okay, you just process through several transformer layers. Okay, you end up just stacking one layer after another layer after another layer, right? And you take the final output and process it through some fully connected layer, just like before. Okay. The question arises, of course, which final output? Because we now have a sequence, right? Let's say I'm doing image classification, okay, which means one label to the entire image, 224 cross 224 image, and you will just assign one single label. Let's say this 224 cross 224 image, you divided into 16 cross 16 patches. So how many patches you got? 224 by 16 into 224 by 16, this many patches you got, right? And so this many patches represented by their feature vector fed into the transformer is treated as a sequence of that particular length, and at every layer you also get the output, okay, as if that many number of outputs are there. Okay, so which output should you take? So at this point of time we have like multiple option. Either we add an extra token, okay, so extra token for the entire image, or what we can do, we could do some kind of pooling, okay, over all the outputs that we get, we can do a pooling, and yeah. So I'm still talking about like the vision transformers, the first paper in the computer vision proposing the vision transformer. So they themselves proposed multiple versions, VIT base, VIT large, VIT huge. You see that they have different number of layers and accordingly different numbers of parameters. And the expectation is that, what is the expectation? That the VIT huge should perform better than the VIT large. VIT large should perform than the VIT base, right? This is the expectation. If this doesn't happen, there is no point. Yeah, I mean, the first this vision transformer paper, they showed the experiments on this ImageNet, the existing already the dataset that I talked to you about, and also some dataset called JFT 300 million. Okay, and this, as you can see here, the this model, basically the VIT large by L by 16 basically sorry, this red is not visible, right? Anyway, so this VIT L by 16, this is indeed the best performing model with the increasing number of pre-training samples. If you take the number of pre-training sample is very low, okay, towards the lower side, not very low actually, I mean that's also in the millions or something. There the other models were performing better, whereas when you increased, this is having a bit, can I use this maybe?
Yeah, this is switch off. This only one.
Okay, you can get that. Yeah, I think I better use this. Yeah. Is it better now? Yeah. Yeah. Sorry. So as you can see that when the number of training samples was less, at that point of time, some other models perform better. But as we increase the number of training samples, the VIT L by 16 that ended up performing the best, right? Okay, so this we already discussed. Yeah, so this is what we just discussed, that a large VIT models perform worse than the ResNets when pre-trained on the small datasets. However, they excel when the pre-trained on the larger datasets. Similarly, the larger VIT variants surpass the smaller ones as the dataset size increases, right? Now I want to take this story into the next level. The thing is, what I said, that I had this problem of that, okay, just having more larger data set, or just having like larger model in the when we were talking about the CNNs, it was not the case that they will always perform better. Okay, at some point with the larger models, actually there was a flip. That's the same thing with the larger data set also, there was a saturation. If not flip, with the larger data set there was a saturation, right? We ended up solving this problem with the transformers. Transformers showed this perform, like I will not go into like why it's able to actually solve it. Then we need to go into the more details of self-attention and all, and at some point it's not even like 100% realized till now, like why it ends up solving this. But it solves, Transformer solves this problem. Transformers is a different kind of architecture than the convolutional neural network, and it solved this problem we saw with these experiments. But then the question that arises is that, okay, how can we just keep making our dataset bigger and bigger? I mean, I am saying if I can make my dataset bigger and bigger, hopefully transformer will keep giving me better and better performance, or at least the performance will not drop. But how can I just keep making my dataset bigger and bigger? Even the example that I gave, that I run a company A, which is slightly poorer, Professor Sunny runs a company B, which is slightly richer. Even then there is a limitation, right? I mean, how much can you actually pay people to like do annotation? You can't. Or even if you just pay people, at some point, I mean, there is human error and all, the data set quality check will not be there, and a lot of issues will keep coming. So you cannot just keep making a data set. When I mean a data set at this point of time is images with their associated labels, right? You cannot just keep on making such a like humongous and more humongous data sets. There the idea of the self-supervision comes in. Like, what if we could somehow train the models without actually having annotated data? Okay, let's say we have just the images. Okay, we don't have the associated labels. Still, we can train the models. Okay, can we do that? And the same thing, this self-supervision, this was actually growing in parallel. Okay, so the timeline, remember the timeline again: 1999 LeNet, 2011 AlexNet, 2010 the ImageNet dataset itself released, 2011 AlexNet, 2014 VGGNet, 2014 GoogleNet, 2015 ResNet. These are all CNN, right? I'm saying till 2020 at least the CNNs reigned in the image processing domain. By 2017, transformer was already proposed in the natural language processing. However, we computer vision, we image analysis people, we don't adopt it till late 2020. Okay, but this study into the self supervision, this was already like gaining momentum from 2016 in the image processing with the CNN based architectures. Okay, so how can we train the networks such that we don't need label data? Okay, so let me very quickly mention a couple of progresses there. So what most of these algorithms, self-supervised learning algorithms, will try to do is that if you have some data, okay, you have an image, okay, and let's say you take a augmented version of this image, like let's say you rotate the image or you add some noise to the image. Are they different images? No, right? They are still the same image, right? Whereas let's say you take a totally different image. You don't need to know the class of these images, okay? You don't have the classes annotated. You just randomly sample these images. You sample two images, image A and image B. From this image A, you created an augmented version A dash, okay? Now you have a function f, okay? F can take two inputs. So first you give this to this f two inputs A and A dash, okay, and the next time you give to this f inputs A and B, okay. So in which case do you expect that this function f, let's say this computes the similarity, image similarity. So in which case it will be, and if it is more similar, let's say the value is higher. So which case will you expect it to produce a higher value? When it's fed with the A and A dash, or when it's fed with the A and B? The first case, right? A and A dash. So this was the basic logic behind like this self-supervised learning algorithm training. And just with this training, then there are a lot of other details and all. So one of the things that really matters in this self-supervised learning is that, so as I said, that from A to A dash, you have to create this by doing some trick, right? So this trick, depending on how difficult this trick is, so you can also create if A dash is equal to A plus 0.1. That's possible, right? But for a neural network so complex, detecting this trick, you are just trying to fool the neural network, right? You are this will, like, in some time it will just understand that this was the trick, just addition of 0.1. This will not fool the neural network, which will mean that this learning mechanism will end up giving you no edge. So you need a mechanism to create this A dash from A, which doesn't totally distort the image, but also doesn't produce something which is very identical to A. So A dash should be as dissimilar to A also possible. So that's what is shown here, like with different kind of augmentation. And when you are taking the augmentation as a combination of, like, this kind of augmentation can be two types. Either you work in the spectral domain, you do some modification in the color, or you work in the spatial domain. That is, you do some trick in the spatially, like you, instead of the entire image, you take like a subset, something like that, image crop. So when you take a combination of these two types, different types, then it gives you the better performance, okay? So this self-supervised learning, this kept on, like people kept on working on this from 2016, 17, 18, 19 with the CNN based architectures basically. And so I will just skip these details. I mean, probably not so much of interest how the self-supervised learning kept on growing in the meantime. So this all is self-supervised learning, and this bootstrap your own latent. This paper itself comes from the 2020, but however still proposed to in the context of the CNN. Okay, one of the important progress that this bootstrap your own latent paper showed is that you don't even need a like a negative sample. So in the previous example, I said that okay, you need A and B. B is basically negative sample, okay, and then from A you are making A dash. right? And then you are using this a comma a dash and a comma b. They showed a progress that okay, you don't even need this negative sample and all. Let us skip these details. However, I will move now to Dino. Okay, so probably the first kind of like what people actually calls computer vision people actually calls a foundation model. So this was given by this Dino probably 2021 maybe, I don't remember exact year. So Dino is nothing. So I already said that the vision transformer, this was already proposed by 2020, late 2020, vision transformer was already there. Vision transformer is nothing but the transformer that was already proposed in 2017 in the natural language processing. The main engineering came from how do we feed the image as a sequence. That was the main engineering came in the vision transformer, but the original vision transformer paper mainly talked about the supervised learning, not self-supervised learning. And as I said that with the supervised learning, at some point you are going to reach that ceiling that you can't have more annotated data, right? So we needed, the solution is that self-supervised learning, because with self-supervised learning, it's just collection of the images. It's not annotating them. You are never hitting the ceiling, right? If you have to just collect the image, I'm not saying collection of images is also possible infinitely, but it's much more feasible than actually annotating them, right? So Dino is nothing but VIT backbone and self-supervised learning. VIT backbone and BYOL, nothing else. Okay, so these algorithms and all of the Dino, let's not go into those. Yeah. So some changes, because the CNN based architecture had something called batch normalization. By Dino, like the vision transformer based architecture did not have them. So those some minor modifications here and there which was needed, but otherwise it's just vision transformer and self-supervised learning, which was already developed in the context of the CNN. That's Dino for you. And you see the Dino, the performance gap with the supervised learning is not that much. The supervised learning at this point of time, so with the VITS, we see that is given 79.8 percent accuracy, I guess, should be accuracy, and the Dino is 77. So it's not a huge gap at all at this point of time. Okay, so from this point onwards, the main challenge in the developing of these foundation models, the models, so foundation models that we are calling them, why we are calling them foundation models? They show this scaling with, like more data. If we can fetch more data, if we can add more layers, they show more scaling in the performance. Okay, so at this point of time, I'm talking about 2021 or early 2022, the main challenge then can become, so since it was shown that vision transformer works well in the image domain, it works better than the CNN based models, then it was shown that vision transformer you can actually train using the self-supervised learning techniques. So at this point of time, the race was more to like how to make even more clever ways of training the vision transformer in self-supervised manner. So one of the mechanism that I showed was from the previous our previous literature on the contrastive learning that was used by the Dino. People then started thinking, can there be some other clever mechanisms also? So there came in autoencoder. Okay, so autoencoder, I guess many of you know the name, even if you're like not so much into machine learning. So what it does is, you give an image or you give an input, basically it compresses it into a bottleneck feature, and from the bottleneck feature it then decompresses it back the input again. That's what the autoencoder does. So the like inspired from the same thing, what was done, this was I think early 2022, people proposed masked image modeling. Okay, so what you do is that you take the input, okay, you take the input, you mask as much as, so this number is very important, you mask as much as 75% of the patches. You take image, you divide it into patches, you mask as much as 75% of the patches, you keep only, let's say, 25% of patches, and feed this 25% of patches, and your training task is to get back all the marks patches, to get back the 75% of those patches that you had dropped in the input. Okay, and vision transformer could do that, and this ended up being one of the most popular or most effective way of training the vision transformer in self-supervised learning mechanism. Okay, this doesn't need any label, right? You take any image, you just divide it into patches and drop the patches. That's all. So this ended up being one of the popular mechanism.
But,
So this.
the dropped ones can have any number of values. Still, how it can reproduce, and how do we know that what it has produced is correct if you don't have initial data? And I want to predict.
Oh, no. So this, see, we have the data. You have to understand,
But you have removed suddenly, so drop it.
input side,
Correct.
but the output side to compute the loss function.
Loss function you compute, I have no problem. Suppose my training is over, I am training a new data.
So this is an important thing that I should explain better. So once you have trained this masked autoencoder, okay, then the encoder of this, so it has an encoder, it has a decoder. The encoder part of this, then you want to reuse in some other task, right? So when you are going to reuse it in some other task of your own, at that point of time, you are not going to drop any more the patches. You are going to feed the entire image. So this masked encoder, just a standard VIT and all. So some details and all we'll skip. Yeah, the masking ratio, you see, like peaks around 75, 73.5. And at this point of time, you know, like the the time masked autoencoder was proposed, I mean, it was actually outperforming the supervised learning networks. So this is really interesting. Yeah. The next level of, this is very important. So the next level of jump that happened in the algorithmic space is that, so till now what I'm talking about is all image, right? So at this point of time, people thought that, okay, can we, because sometimes it's possible actually to get the pairs of the image and the text, right? Like you are crawling some images from the websites or something, on newspapers. So image comes with text, right? So can you use that text together with the images? So that kind of acts as a kind of natural supervision. So you don't actually sit and annotate, but you are crawling from some source. You take the accompanied text as a kind of supervision. So this, I mean, image and text, this also goes back in history in the form of the image captioning. It goes 15, 20 years, but image inspired from this, I mean, this model was proposed, CLIP, which is one of the most popular computer vision foundation model today, which does nothing but just like you have the image, you have the accompanied text, image is passed through like an image encoder, the text is passed through like a text encoder, and the expectation is that the features produced in both cases should be similar. Okay, so if I take my image and the corresponding text, they should give me the most similar feature representation, whereas my image and any other text should give me the differing feature representation. So this was very simple training task, and this ends up giving us like a quite good result. And the object detection that that was talked about, for that also we see like really good performance with the same kind of mechanism. So there is a model called OWL V2, proposed by Google, if I remember well. The next jump was a segmentation with the prompts. Okay, so you give some kind of prompt, based on that previously what used to happen is that, okay, you want to segment into 5 classes: water, building, road, grass, and something else, 5 classes. Okay, so you have to make a data set with those 5 classes and all, and you have to train with that training objective. But now this all changed, okay, and we started asking question that, okay, if we have trained like a segmentation network with humongous amount of data, now to the end user, can it be just like, choosing a point on the image and saying that this is the object that I want, and the model gives me back, okay, model reads my mind with those 1 point prompt. So this point, green point you see is the prompt, and the model reads my mind and gives me kind of, like the frogs partly, not fully, right? It's not 100% accurate. What you can do is that you can add more prompts. I added one more point and the segmentation is better, right? Is it perfect? It's not yet perfect because it's also detected this snail, right? So you add one more thing, prompt, that is a red point, okay? And now the segmentation is perfect, right? As if it read my mind. It was never, this is from segment anything model, SAM. This was never trained with the objective of actually segmenting frog. But when I gave these 3 points, it kind of read my mind and it gave me the frog, okay? So this was the next kind of jump. SAM actually is trained with that mask structure encoder strategy.
Is it because of different color?
Sorry?
Snail.
Uh-huh.
Is it because the snail is of a different color?
Snail, yeah, I mean at the end it's the color also.
We don't know. It can remove.
Yeah, it has at this point of time, it has understood that this is a different object. Of course, the color is a very important cue, but also from the texture and all also. So it understood that this is a different object and it has removed. This allows us to, like provide human supervision plus AI augmentation to, like you can use this SAM model to create humongous data sets very quickly. So the annotation, I said annotation is a problem. With the SAM, you understand, if you're using SAM, this problem that I talked before, annotation, this problem itself gets solved to a reasonable extent. If you want to annotate something, if you want to, like Professor Das keeps, some of you might be Professor Das student, and Professor Das gives you like a labeling task, never start with, like opening a tool and like labeling pixel by pixel. Start with the SAM and you will save like, 1,000 images, 10,000 images. You will just come and deliver to Professor Das the next day, and he will be really happy that, okay, it was done in single day. So segment anything model, again, let me skip all those details. The next thing that I want to quickly mention is the text to image generation, okay? So this is something, again, probably many of you have played with, even if you have very less exposure to all the CNN's transformer, the stories that I told you, but many of you have actually played with this text to image generation, or Instagram is full always with, like generated videos and all, right? So this came up in 2023, sometime in 2023, text to image generation. We already had the generative models in the term of the generative adversarial network and all. However, they had the limitations, whereas this technology, which came in the diffusion, this technology, this took it to the next level. And this is an example of a synthetic image. The prompt, anyone would like to guess the prompt that I gave to generate this scene? Yeah, it's the prompt that I had to give is the aerial view of a building, okay? So if I just give a building, it doesn't produce something like this. So this was the next step. Now, I will very quickly, like take another 10 minutes or so. I'll very quickly show you some examples, like how we are kind of adapting, okay, these foundation models to like different tasks. So the first example that I quickly want to, so remember SAM again. What was SAM? You had the image. You have the image. You can give the point prompts. Okay, you can interactively give the point prompts, right? And you can get a segmentation. However, in ideal situation, I mean, when you are working with many images, you don't want to give the point prompts by hand, right? That's not how it will work. We created this one example semantic segmentation. So you have a example image. Example image means the image and also the mask, corresponding mask of the object that you want. Just one example, nothing else. And you have the SAM model. That's all. Okay. So no training phase involved. The SAM is already trained and all. We are using the SAM as it is and with one example image. So what we have, one example image, one query image, which we want to segment. Example image shows us the example segmentation of the class that we want. The query image, this is where we actually want to segment, right? And the SAM model, right? So we have to somehow like make a pseudo interactive mechanism, right? As if we are working in interactive domain. So one easy way, just think of it. What you could do is that take the example image, take the query image. For now, assume that they are of the same dimension. I mean, they need not be of same dimension. For now, assume they are of the same dimension. What you could do, you could simply put them side by side, right? You could simply put them side by side and kind of consider now this stitched. Let's say 256, 256, 256, 256. This was the two images. You put them side by side, it becomes 256 into 512. Now you simply start thinking that this 256 or 512 is the same image. Okay, there are some boundary discontinuities there. Forget that. You can just think that, okay, like this is as if this is the same image. Okay, now on this image, this example image side, let's say example image is on the left side of this image, stitched image. The example image side, you know the segmentation mask, right? So now your computer program can choose those positive points and negative points from your left side of the image because it knows the segmentation mask to the left side, and expect that on the right side of the image the segmentation is now the SAM model produces a output where both for the left and the right side it gives you the segmentation of the desired class. Ideally it should work, right? What SAM needs? SAM needs an image, SAM needs some prompts, point-based prompts. You have given everything, right? You will expect it to work. However, it turns out it doesn't work. Okay, why it doesn't work? Because SAM also has a spatial bias. Okay, what kind of spatial bias? If your prompts are all from the left side of the image, SAM starts thinking the object that I'm expected to produce is probably from the left side, probably from this side of the image. It thinks that probably since I have got no prompt from the other side of the image, probably my object of interest is not on the other side.
You are trained that the subset remove.
Yeah, I mean they have probably not taken this into consideration. Since we have not trained it, Sam, right? It's so released by Facebook, so they seems to have not taken this into consideration somehow. So we solve this problem in this way. Flip, I don't know. I mean, if we could flip and give, but the solution that we used, that's also very simple actually. So what we do is, so the first one, the first example is this example that I was talking about where this left side is basically the example image, the right side is the query image, and you choose all your prompts from the left side of the image, right? See the second solution. There are two other solutions also, ignore them for now. Just see the second solution. What we did is that we also produced a green or the positive prompt from the right side of the image also. Okay. To tell Sam that you have to give me the segmentation output from the right side as well. Now the next question that will automatically come in is that I don't know the segmentation mask of the right side, right? That was all I wanted to solve. Then how can I give the green prompt from the positive side? Impossible, right? So what I can do is that I can rather randomly pick a point. I don't know. So in this case, what I'm trying to segment is buildings. Okay. So I don't really know that this doesn't work. I don't really know that a randomly sampled point will actually fall on the building on the right side of the image, right? I have no idea. Okay. In fact, I actually don't even know. This is a one example segmentation. I don't even know this name building here. It's just for your and my understanding, I'm telling. The SAM model just has seen this one single example. Okay. So what will happen? Now, one thing that I didn't tell you about SAM is that SAM also gives you a confidence score. Okay, not just the segmentation mask, SAM gives you a confidence score. So run it once. On the left side, all my prompts are fine, right? On the right side, I randomly sample the prompt. Let's say my prompt fell rather on the car. SAM will produce some segmentation output. SAM is engineered to like produce some segmentation output. But however, will you expect the confidence score to be high or low? Low. As Professor Das has said that it will be low. Why? Because SAM is seen from the left side of the image, I am seeing buildings. Okay. On the right side, I am seeing car. As green prompt, it gets confused. Like, what am I actually supposed to produce? It gives a low confidence. You run it again, you keep on running, you can fix like a k value, okay, like let's say k is equal to 20, you run it 20 times. The time that it will actually fall on the building, okay, the same class as your example image, it will fall there, it will produce a high confidence. Now you can just filter by the confidence, you can get the best output. And this gives you already like a good result. So this is one of the things. There are some examples of building segmentation, vehicle segmentation, which is so difficult task actually, because vehicles are so small. This also works reasonably actually for the vehicle segmentation as well. Then one of the one more modification that we have made using the same kind of strategy. SAM guided segmentation, SAM guided one example segmentation is the detecting specialized change with the unsupervised change detection mechanisms. So the unsupervised change detection mechanisms, they don't use, like they don't train end to end for like a change detection. So there are like change detection in the earth observation. So like let's say like there is this building here, and tomorrow unfortunately an earthquake happens. I don't want this to happen, but tomorrow if it happens, there is this building doesn't exist anymore. Okay, so this is one kind of change, but this is also a kind of change which probably you can foresee. Like a lot of earthquake has happened around the world, and you can actually think about this, create a data set, and you can train a network for this. But then there are so many other kind of changes that keeps on happening that people have not even thought about. So like the disasters, cyclones and all, and the kind of things that happens, people have not even thought about. So it's not possible, like to actually train for all kind of changes. And if you just train like for a subset of like few particular types of changes, like this building change and all, this will not work for all kind of changes. Okay, so that's where the unsupervised change detection comes into play, because unsupervised change detection, they don't use this end-to-end training. They still use deep networks as feature extractor, but don't use the end-to-end training. However, the issue with the unsupervised change detection is that unsupervised change detection will throw you all kind of changes as output. This will not give you the specific kind of change detection output that you want. So we are in a loop, right? And right now, then you will say that then how can I get a specific kind of change? If I had a label data set, but if I had a label data set, I would have just done supervised change detection, right? Why unsupervised? So there comes this question that, okay, if we had like only few example images of the particular class that I want, and can I use unsupervised change detection? And this part, and maybe something more to detect that particular change. So this is where what we did is that we used the unsupervised change detection, and we use this SAM guided segmentation. So the segmentation mechanism that we just showed before, this doesn't need a lot of images, right? This we only one example image, let's say. So these two results, then we can have like a kind of, like OR function and function this all. So intersection we took basically. So here are a few examples where we are showing the particular change of the class building to other. Okay, so this building to other, of course, building to other is like a change type for which you could have trained a supervised model as well. However, here we are doing in like totally unsupervised manner. So if it works, then for any other class also where it's difficult to train actually like a supervised network, it will work for that as well. So the D is basically the, if you're curious, D is the result from this method of like unsupervised change detection plus SAM, this combination. And the other results are like from different other methods, and C is the reference image. So you see like C and D has reasonable match. Then another work that we are working on is the text guided object detection. So if we can combine, combine the SAM-based mechanism with, so what is the SAM-based segmentation mechanism that we said that we have one example image. Okay. So instead of one example image, if we have just a textual description of the class. So what we could do is we can start with this text query, let's say built-in, and we can use the diffusion based synthetic examples. We can generate the diffusion based synthetic examples. On the top of this, then we can use the SAM based mechanism that we just talked about before. Then this is almost last slide, 1 or 2 minutes more. Then another line of work that we have recently started to explore, and where which also matches with the theme of this conference of explainability and all, is the visual chain of thoughts. So visual chain of thoughts is also something in computer vision we have borrowed from the NLP people. What it tries to do is that this visual chain of thoughts is that not just produce an output label or something, additionally explain this output with additional some images, some text, something like that. So this so if this was the input, that was the output, so you produce like some intermediate visual steps. That's the basic idea. So what we are doing is that creating the unexpected semantic change with this visual chain of thoughts, where let's say given not just 2 images, I'm talking about a number of images, sequence of images. So given a sequence, okay, understand something, in some cases change is normal. Like let's say you are taking the images through the summer monsoon seasons and all, starting from some winter or something. It's very normal that some places where there were low vegetation had almost disappeared. This low vegetation has come back over the time, right? There is nothing exceptional in this, right? It is also a change. If you just take 2 images, it's also a change, but otherwise it's nothing exceptional. So if you take now a time series of the images, you will see that, okay, the vegetation, slow vegetation, the grass is coming back slowly, and will be captured as different level of intensities, maybe from the bare soil to some grasses, something like that. Whereas the unexpected changes, this building not been present anymore tomorrow, bad example, sorry. So this this particular case, this
New building coming up
in a day, new building coming up.
New buildings coming up which are illegal. You go and tap this, but really we are doing it to end.
No, there are 2 cases here. So one is that new building really coming up, taking 1 year of time.
Which is not there as per the municipal record.
So that's of course is there, but new building coming up taking, if it takes 1 year of time, it will not be captured in this unexpected change, because for the time series it will be something happening slowly.
Time lag.
With the time lag, the previous example that will work for this, but unexpected here more means something not captured in the time series. So there, what it will do is that it will produce what kind of output which was actually expected. So in addition to giving these pixels, annotating that these pixels are the unexpected changes, it will also produce the visual chain of thought that what it was actually seen, expecting to happen. Okay. With this, this is a kind of advertisement slide, but before going to that advertisement slide, I would like to say that not everything is still perfect, I probably presented in a way that everything now sounds perfect. I mean, when we were in LeNet in 1998, there was so much of problems and issues, and now transformers, foundation models, and can do everything maybe. That's not the case. And I intentionally put one example of that, which I don't know if any of you have noticed. So I will take you back. this all V2, okay, what it does, it given a text, it tries to produce a object bounding box. I asked a text to language model to produce this for me, this image, instead of me working on this. And just try to see this image. It has produced, I mean, if you spend just 10 seconds on this, probably you will be fooled, but now give like a 30 seconds or something. Does it make sense? It got the text prompt, it produced some image encoding from the text prompt. No, I'm not talking background at all. So I'm not talking the background of what it has produced, the logic. Does it, of course, what you're saying is also makes sense. I mean, the background of the image and later what was produced has totally changed. But even leaving that, the whole thing is actually totally nonsense. From the text from it's producing image embedding and it's doing whatnot. I mean, so this is where we are. There is a lot of work still to be done. We are just not even halfway through, I will say. The foundation model research, vision foundation model, both aspect, like there is one aspect is actually designing these vision foundation models. Why it is?
Use this total nonsense, let's say.
So I explained. So if you see this, first of all, see like this text prompt it took and it's passing through the image encoding. Should be text encoding. The ROI features this belongs out of nowhere, like it's not connected to really anything. So there's a lot of like slacks. It doesn't really explain anything. I mean, if
we have provided on the top.
Actually, the scooter image is not there. Also, I need to produce.
Yeah. So, so this is how it is. Both in the like there is a lot of scope of the research, both in the like the like the foundation model creation of these foundation models, more theoretical, and also how to apply these foundation models more applied in both of these domains. There is a lot of still a lot of scope of research. So there I come to my advertisement slide and.
Responsibly.
Yeah, irresponsible AI. So there I come to my advertisement slide and finish. So I'm an assistant professor at the School of Artificial Intelligence at IIT Delhi. Right now I'm leading a small research group which we call Learning for Earth, abbreviated as LE. So LE strikes a bell. I started with this LENET, right? Where all this computer vision things started. So that's why we call the lab LE Lab. So we are still at that beginning. We have 2 PhD students, several master students, and a couple of projects as well. We are actively seeking PhD students. In our department, we generally admit PhD students twice a year, summer and also in the winter. So you can get some, the processes and all are available there. Yes, that's all from my side. Thank you.
Can you tell me how it can be misused?
I
I can create a passport, I can create an Aadhaar card, I can create some photo in Aadhaar card and make it.
So
Pictures sometimes unethical, isn't it?
yeah, I mean, that's a totally different aspect.
Immigration won't accept that.
Yeah.
Immigration department doesn't accept.
First of
That's why the technique I wanted to know. How to know whether it's genuine or not? That is another technology.
So there are, detecting the differences between the fake images, synthetically generated images, and the real images. This is also something, I mean, a parallel line of research. However, this gap, of course, keeps on.
Regulation. That sometimes trying to be imposed. Anything is AI generated, it's a big one. It is AI generated.
So
Follow it.
that regulation will not stop like the fraudsters to. If it is like you are actually using, let's say, like some tool, online available tool, like ChatGPT or something, tools will produce it, but you can always, let's say, get the if I know correctly, let's say like the Perplexity AI, they probably released the embeddings as well. So you could just, if you have that capacity, if you can just have the, like the same thing inbuilt in your house, okay, and then you can just run. Yeah.
Big companies to be responsible, right?
They will be responsible, but the issue is that if you are that kind of big, I mean, small scamsters.
Six can find out.
Huh.
Ordinary people.
Yeah. Okay.
Thank you, Professor Sudipin sir, for your insightful talk on Earth observations and generative AI as well. So ma'am, now I would like to call upon Shri Preet Yadav for his keynote. Sir, over to you. Yeah. Should I connect it to Zoom? Zoom.
No, you have this
Someone
laptop on.
Wi-Fi Zoom.
Yes.
నేను ఉట్టిగా కూడా అవ్వలేదు.
Key and password.
Yeah, what do you mean, sir?
Slide changer hai?
Shall I take this?
You change the slides for me.
Yeah.
Okay. Okay, good evening. I see the room full till the end, but there are some seats available in the middle. So if you want, you can come forward, but I'm fine with that. And I'm told that I have 45 minutes to go for the topic I wanted to, discuss with you all. So I think we had a quick intro this morning. My name is Preet. I work for NXP and I'm chair for IEEE Circuit and System Society Delhi chapter. And okay, this is working. Okay, yeah, great. Okay, so I'm going to talk about the future of AI-driven mobility, how AI is shaping up the future of automotive. We'll talk about connected, autonomous, and the smart vehicles. I have a quick video to play here. I assume the audio would be. Can you move to the next slide, please? Okay. Seems like this audio is not shared. No, so maybe you can keep the mic here. That's okay. That's fine. Shared audio. Go to this. No, don't show the desktop. Stop sharing. Only share the window. I have so many other things on the desktop window. Can go on full screen. Go on full screen, please. F5. Now you play. Yes, do next slide. Maybe you can give me this, I can do next. I can just do it from here. Okay, so great. So in this audio, I was trying to show what all different AI-related great things are happening in terms of automobiles or mobility front. Starting with your access to the car, which is a keyless entry these days. You need to physically plug in any key to get inside your car. You have the key sitting inside your pocket, but the car is able to detect the key, and the technology uses ultra wideband UWB, which can authorize whether this person who's entering inside the car is authorized or have the right access to get inside the car or not. And the moment you get inside your cars these days, the cars are smart enough, they would have different modes plugged in. Now let's say there's a car shared by me and maybe my other family members. Each one of us can have our own customized settings in the car, and that could be starting from the settings for your seat, how elevated your seat should be, or how elevated your back should be. Okay, from the ambient temperature, your preferred music, the way you want the Google Maps to or some maps to show up. There are different settings within the map, and I always have a struggle with my little one. He will own traffic all the times, and I'll keep it off. So the moment I enter inside the car will realize, okay, I'm the authorized, person to get inside the car. And the moment I take my front seat, the car would be able to, detect, okay, this is the, object A or a person A or person B or person C. And the moment car gets to know the person A is inside the car, they will set the, temperature the way I wanted it, the set of playlists which I prefer to be, and the Google Map setting or other infotainment, probably the lighting of inside the car, from the blue to green to red to yellow. So those all kind of can be detected and can be enabled with AI. There were many other good things shown here in this particular video, starting with autonomous vehicle which is on the road. Again, AI plays a huge role in that. And then things like let's say you're going on a particular junction, and there's another autonomous vehicle coming from the vertical diagonally opposite direction. So here this V2V will come, vehicle to vehicle technology, where this car will talk to the other car, and they'll get to know what time we are intersecting on the junction, and accordingly they'll adjust their speed. So largely in this today's talk, I'm going to talk about how this whole automobile industry is shifting, how this whole architecture is evolving. I don't think so I'll have time to get to the architect level, but at least I can give you the top three domains in which large part of work is happening within the automobile industry. So let's get started. This is about the organization I work for. Together we pioneer solutions at NXP and solution for a better world, a better technology for tomorrow. This particular organization I represent, NXP Semiconductor, which is the legacy, Philips Semiconductor, which became NXC in early 2000s. We have presence more than 60 years in total of experience, 33,000 plus employees across the globe, operations in 30 plus countries, and a huge value comes from these patents, 9,500 and plus, and we are really counting more on each day we pass by. So that shows the depth of innovation which is happening inside the organization. I have a couple of two more files to talk about the organization. We are spread all across the globe, as you can see on the screen. Almost each part of the world we have our presence. We are based out of Eindhoven, which is Netherlands. It's a Dutch company. That's where our headquarters is. And these are the various presence in terms of fabs, in terms of packaging units, OSAT in different part of the world. We don't have any of the manufacturing in India. We do have our design sites in India, and we have 4 of them, which is covered in this slide. We have offices in Noida, in Bengaluru, in Hyderabad, and in Pune. Almost 1/4 of the global research and development R&D team is based out of India. So India is a really focused destination when it comes to R&D for NXP. We could do almost all kind of functional work out of NXP side. The different level of expertise we have built all together. And certainly, a smarter world starts with NXP. We are big time in automotive semiconductor and industrial and IoT, which is again a big market, because with Industry 4.0, everything is getting from manual to auto mode, and a huge number of industrial IoT has to come into the play, and that's where we position ourselves. We are pioneered when it comes to AI at the edge. We were talking about the mega trends of by Computer Society, Sir was mentioning this morning, and one of the major driven forces there, AI at the edge. So edge is very important. Edge is at the worst, at the edge, kinara of the stage. Everything which is happening then and there. We recently acquired a company named Kinara, which is again pioneer in the edge computing. Because what is happening is the world is changing so fast and the technology is evolving so fast that we don't have patience to detect something, send it to our servers backend where a huge computer is sitting and do this whole compute. Based on that compute, based on that data which gets calculated out of this whole combination and permutations, we need to govern an action which comes back to the device again, and then based on that action, this device needs to act. And there's a huge time gap, I would say, involved sending this whole data from this device to the backend servers, doing the compute, getting the instruction back, and then acting on it. At the same time, it's not only the time, it is the money. You need money to do this communication on both of the sides. So we want this compute at the edge to be smart enough to do all of this post processing of the data and go on a signal out of it. Let's take example of automotive vehicle. If there's a vehicle on the road, you just can't wait for 5 seconds the instruction to come back by the time the vehicle would hit someone. Okay, so that's where we position ourselves as the organization, a pioneer in the AI edge computing. Let's quickly talk about a few of the numbers. The growth of semiconductors in India. By 2030, this whole semiconductor market globally is expected to cross $1 trillion. And we, back in India, we are expecting 10% of that global market, which is about $100 billion by 2030, another 5 years from now. That's the quantum of growth we expect. As you can see, largely this growth is gone by few of these sectors: compute and data storage, automotive electronics, and the third is wireless communication. Certainly the other sectors have their own pie of I would say work in it, but largely these are the sectors which are going to drive the whole growth. And I'll be touching upon mostly on the automotive side of it in today's talk. And I request Dr. Sujata to just keep me warm about the timing, okay? I was already instructed to keep it crisp, but I will try to, give the gist of it. So our world is changing. Things which we never thought of ever in the past are happening, Never, no one thought of, COVID happening other than few Bollywood movies, but that happened actually. No one thought of we'll be using digital payments the way we use it. Let me give you some figures. Globally, about 638 billion transactions are done by one of our leading, this card vendor. I'll not say it's MasterCard or Visa, I'm not going to name them, but they do 638 billion transactions. And in India, we do 640 billion transactions using UPIs. Okay, so that's the quantum of digitalization which has happened in India. And I would give this whole credit to COVID, because we never thought of this whole digital payments would reach out to every single food vendor, to a vegetable seller, to a golgappa wala, I don't know, you call it pani puri or what here. So but even minute payment of 5 rupees, you get a Xerox done, you need 2 rupees, this guy don't have change, I don't have change, scan it, done. Okay, you want to make certainly nowadays I saw that someone was saying that in the weddings, that shagun thing, they have the scanners, easy credit, instantly, no compute. Because when I was kid, I used to be one of the sincere one in my family, and my job was sitting with those old elderly big guys, my grandpas, and doing the math for them for whole of the shagun you collected in the wedding. Okay, and you don't want to slip even 100 rupees here and there, because you're doing it for the third party, one of your relatives. You can't give them, 100 rupees I received but I lost it. But anyway, this digitalization has gone to a different orbit altogether, and the world is leading from learning this from India. Even that COVID drive which we did, we created this COVID portal, and we end up selling it to many different countries. Okay, so digitalization has gone to a new level of toss with this whole world. And few examples you can see is even a healthcare. The number of Fitbits or these digital watches which are sold in India is amazing numbers, because those are cheap, affordable. It's a stunt, for me, I love analog watches, but people just love it, and you get instant, numbers, be it your heartbeat, be it your blood sugar levels, be it your blood pressure, etc., etc. At the middle bottom, this is something I experienced personally as well. Back in the Western world, most of these deliveries are no more done by humans. And you can go to places like California, go to Texas, Austin, you will see these robots out on the delivery. So all this automation has two parts of it. One certainly is AI, and second most is semiconductors. Without two of these, it's next to impossible to get to such level of automation. And today in this talk, I'll be talking more about the automotive side of it. So it's not only this whole digitalization has happened in healthcare, consumer products, and or industrial IoT, but in the automobile as well. What you see on the picture is a picture of the very first car, which was about 140 years back. And if I'm not wrong, in the month of January, this patent was applied, and in the month of July, this car went for a public outing where people were able to see it. And more than a century now, this structure has really changed. Oh, sorry. So this is how a typical car these days looks like, full of electronics sitting inside it. And then these, I would say, hundreds of thousands of those semiconductors talking to each other. Okay, and then you have all of the wire harnessing, running through. Can anyone in this room guess what kind of length of these wires would be within just a single piece of car? What could be the length of wiring within it? Well, I can make out you're really wise, more wiser than me.
15 kilometers.
Certainly. So So it is not into, meters or feet, it's in kilometers. That's the kind.
Rockets where we have say routine.
Certainly, rocket is a big example. But this whole wire has a huge, weight in it. The wire harnessing weight itself is in like 50 kg or more than that. A car which has a passenger to be, to be transported from one place to the other place, or a goods to be transported, has to transport this whole, wire thing every single day. What if I reduce this whole wire thing? 50 kg of less weight means less fuel, more efficient car. So let's see what goes in the background of these whole cars. So accelerating road to vision zero, there are three topics I'm going to touch upon. First one is autonomy. And when we say autonomy, we say zero road accidents. We lost millions of lives every single year on this earth, and 94% of these lives are lost due to negligence by the driver, by the human, I would say. And for a moment, if I remove this human outside the car, I can save those 94% of lives. And that's possible with autonomous vehicle. So anyone in this room who have heard about the term ADAS system? Please raise your hands. I know I need to, wrap up this fast. I will not ask much of questions today. So these are, the driver assistance system for autonomous vehicle. And how it works, it has different levels of autonomy. Okay, we start with level 0, which is the typical car, where there is, a driver in the control. Then comes the level 1, wherein we have things like, adaptive, cruise mode on, I would say. Okay, go to level 2, where you have the adaptive, cruise available, wherein if you are suppose riding at a single say speed of 50 miles an hour, but vehicle in front of you is, let's assume, running at the 60 miles an hour, and you set your speed say 65, this car will still follow 60 until the front vehicle is there, and this car will maintain the same distance. And the moment the front vehicle jumps up speed, this car will get, but limit itself to the 65. Okay, that's adaptive cruise. And in that, the other part of it is the lane detection. The car would detect the lane if the lane is moving left to right. And I personally experienced this last year for one of the rides I did from Newark to Washington DC. I was lucky to hire a car, and this car was having a level 2 cruise enabled. But what happens next? In the next level, level 3, the car is able to run in a predefined use cases. The latitude longitude control is with the autonomous system, but we still need a driver at the helm of it. And what happens to the next level, level 4, where the driver only needs to sit and monitor the system. This driver is not supposed to drive the car or take it left, right, or speed up or brake it, but the driver should be available inside the car. What if the car hits its use case, the limits? Then the car should give enough time for this driver to take control of the vehicle and get it to the safe state. So that's the level of autonomy we talk about. And if we talk about level 5, that's all autonomous. No driver is required inside the car. The car is smart enough, intelligent enough, to move from one place to other place. And what if there is some obstacle or diversion on the route? The car is smart enough to detect even those diversions and reroute based on the I would say instruction from the map, Google Maps, or some other maps. I'm not favoring only one of those vendors. So that's the level of autonomy we expect. And what is the benefit of this autonomy? Certainly, we save 94% of lives. And ultimately, you have one more passenger seat in your car. You need not to have the driver sitting occupying that particular seat. And maybe in future, this whole use case of public transport would change, because there's no driver sitting in it. These transport might become your restaurants. You want to have a dine somewhere, but at the same time you want to go to Puri from Bhubaneswar. You get inside the vehicle, you have your food, and by the time you reach your destination, you're done with your meal and you're at your destination. Those kind of autonomy, the world is talking about. The other big trend which is happening is electrification, zero emission. So car is no more, the typical only mechanical device. It has moving more and more towards electrification. One part of electrification is certainly, coming from the autonomous side of it. You need a lot of semiconductor working inside it. But at the same time, the other shift is happening is getting rid of internal combustion engines, IC engines. And again, there's different levels. See, we start, say, E0, E1, E2, E3, E4, and E5. So E0 is your typical car, which most of India drives these days. E1 is where you have, a battery pack sitting inside the car, but you're not plugging this car in to charge the battery. The battery is getting charged with the motion, and when you apply brakes, that whole energy gets stored in, and that's being utilized. Now, if you go to the next level of it, the car would have both internal combustion engine and electric setup. So you can, toggle between two of them. Let's assume if you're running from a speed of say 30 or 40 kilometers hour, probably you are still using the battery, and if you bump up speed more, it gets through the internal combustion engine. But if you go to the higher end of the car, which is fully electric, whereas there's no internal combustion engine, there's an electric motor which is driving your vehicle, and that needs to be plugged into external power source to charge this battery for you. And there's a lot of innovation happening in that you don't want to spend your time more than the time you spend to refill your tank. You want all this big pack of batteries to get charged within the same time duration you spend going to a gas station, or in India we call it as a petrol station, to refill your tank or refuel your tank. So how do we do these fast charging? And the second part of it is, can I go extra mile with the same charge? The last part of it is, how do I extend life of my battery? If my battery is lasting 3 years now, how do I use it for 5 years? Ideally getting to a situation where you have these tiny gadgets, mobile phone sitting in your pocket. Every morning you plug in. Nowadays there's another trend, you have the battery pack with you, that power bank which you want to carry every time with you. But what if I tell you we will have a phone wherein once you buy the phone and you need not to charge it for rest of your lives? You pick up a phone, and until the phone has its life, you need not to charge it. Certainly possible, because we have 98.4 sitting in every body. How do I use that particular heat to charge my stuff? If I'm walking, I'm producing some kind of energy. I'm using this friction. Can I use that to power up my device, at least the device which is sitting in my pocket? If I'm, say, traveling, and there are many devices, I'll not name the country, they have many small toys which can function those toys with this inside room light. They don't need even the sunlight. Can I pick up some source of energy and get inside my phone using those all light sources inside the room or outside the room? If I'm with this heat, big sun, can I utilize that heat to charge up my phone or charge up my car? Our transportation, the local transport of our buses, while they're on the road, they are exposed to the sun. Can we get them charged? We're talking about smart roads, wherein when a vehicle is being driven, it is getting charged with that motion itself. So all those kind of good things are happening, because on the one side we are solving the problem of emission with electric vehicle, because we want to get rid of all this lead mercury coming out of our internal combustion engine. But at the same time, if I'm charging my vehicle from the electricity which is being produced by burning coal, I'm not solving the problem. I'm just shifting my problem left to right.
Electric car also is electric. We also, lithium doesn't come this way.
And that's what I'm saying. So how do we optimize with the less? How do we get more? Can we have a battery other than lithium ion? Some other material? Okay, because nowadays with this whole geopolitical equation around the world, people are talking about, this is my rare earth metal, I'm not going to give it to you. Even if I don't know how to use it, I'm not going to give it to you. So the equation is becoming more and more complicated. Certainly, one is technology, and other is Atmanirbhar. Atmanirbhar India, Atmanirbhar ABC, all the countries. Earlier, we wanted to be globalized. Everyone wants to go and partner with 10 different countries. Now everyone said, "Oh, I want to be self-sufficient." So a lot of innovation has gone in the background on this whole electrification thing. People are talking about, selling this energy. So if I have my battery fully charged and I'm in a parking lot and there's a car next to me who has 10% battery left, can this guy, buy this charge from me? And maybe I'll say that, well, I'm going to charge you 2x of it. People are talking about that, okay, during the day, a typical semiconductor engineer like me who goes to office say 8 9 a.m. and I don't know what time I leave for the day, the whole day vehicle is parked. Okay, if I'm withdrawing that energy whole day and if I have a storage enough, when I go back home I can use that energy which I might have got from the say solar sun to power up my microwave oven when I'm back home. So it is going to be the two way. One is we are consuming electricity. Other way, can I sell it off to the the maybe other person who's in need? These days, if I'm not wrong, I think in the electricity board we are talking about regulations where you have electricity connection in your home, you can use the electricity. But what if you have a surplus power coming from your solar system, which is producing more power than your own consumption? How do I sell it back to the electricity board? So two way, how do I get it or how give it? When I have surplus, I give it to them. When I am not able to make much electricity, let's talk about a house in back in northern part of India in Delhi where you don't see sun in the peak of winters. So both of those can be done. We are doing it at the house. I want to do it in my car. I want to produce more energy in my car if I'm all the day in the sun, and I want to sell it off to whoever needs it. So those all kind of good, innovations are happening. The other big trend which is ongoing, and I need to keep an eye on my time watch, is in terms of the connectivity. And when we talk about connectivity, it is connectivity first of all within the vehicle. Okay, if I'm sitting inside the car, how this, I call car is something we call it as a robot on the wheel. How do I interact with this gadget? How this gadget can interact to my phone, my laptop, my digital watch, my iPad, etc. At the same time, this particular gadget, this particular car, how this car can talk to the other car, V2V. How this car can talk to the infrastructure, which we call it as V2X. And then create a mind map. Let's assume you want to go from here. Again, let me give you example of Konark. I've been to 3 places only in Odisha, Bhubaneswar, Konark and Puri. If you want to go that route, the car can, find out who else is heading towards the same route. And if it is going to be peak by the time you reach there. Do you want to start your trip, your visit a little early, or do you want to push it out by an hour? Okay, so those all kind of connectivity, connectivity through Bluetooth, connectivity through Wi-Fi, through Zigbee, etc., is being talked about. Connectivity through, your radio channels. So one of the early example where in a car get hacked was, one of the Jeep one, where the hacker got inside the car through the radio channel. Because no one thought of why to secure radio, AM, FM is all open. And this guy got inside the radio, got inside the car, took control of the steering and the braking system. Okay, so one side technology is advancing, but at the same side, they are flip side of it. So all those kind of good things are happening in terms of connectivity, and this comprehensive system solutions with safety and security built in. Because you're putting so much of semiconductor or electronics inside this vehicle, you want this to be safe and secure. And many times I have seen, many of the students, they get confused. They think safety and security are synonyms, but they are not. So when we talk about safety, it is the functional safety where we talk about in automotive vehicles, FUSA. which is compliant to say ISO 26262, where one need to be ensured that whatever system we are building inside the car has to be compliant to these standards, because there's a life behind the wheel all the time. But when we talk about security, it is the security of your vehicle, so that this doesn't get, no one else can come, and steal your car or a system within the car. We are talking about digital keys. We talk about, ultra wideband. With all those digital keys, if my phone is ultra wideband compliant, I need not even carry the physical key inside my pocket. If I have my phone would give me access to the car. If I'm sitting here in Bhubaneswar, back in Delhi, someone wants my car key, I can simply transfer that car key from my phone to his or her phone. You need not to physically hand it over this key to the other guy. So all those kind of, disruption are happening, but at the same time, those needs to be safe for the passenger inside the vehicle, for the, pedestrian or the other passenger inside the other vehicle, and need to be, safe for all of us. And when we talk about safety, this has to be gone for all the shelf life of this vehicle. If the car is going to be last for, say, next 1 decade, then how do we ensure this car doesn't get hacked in next 10 years? Because this whole compute would advance like anything in next 1 decade. Will I have something which we call it as, quantum compute available with me who can come and hack my car? Do we have that level of security inbuilt today? Because you can't go every day and upgrade safety of your car. So those are the I would say major areas I just wanted to bring up to the knowledge of the audience. At NXP, these are the major technology vectors for any smart device, which is sense, think, connect, and act. First, you need to sense what's happening. Then you need to think. You need to process that information. Then you need to connect. You need to either do the edge computing or do back-end computing, and connect with the other object which is involved, and then act on it based upon whatever information data you got. You need to act on it. So at NXP, we are at core of it, and we have huge offering in terms of technology terms, starting from cloud infrastructure to enable technologies to the edge-to-edge computing, be it home automation, be it auto gateways, be it voice assistant, be it healthcare and whatnot. Quickly, and I would wrap up maybe another couple of minutes here, is about first we talk about the simple three-wheeled car to a complex structure. But how the future cars would look like? They would be software-defined vehicles. Functions can be anywhere in the vehicle. You need not to have a single computer available. Flexible architecture means the architecture is not fixed for the life. You have one architecture for today, and tomorrow if you have a new operating system or a new version of the operating system, the car gets a new avatar. It's like iOS. Once you move from one iOS to the other iOS, the same physical hardware, the same phone looks pretty different. And we at NXP, we define that, okay, the software defined vehicle, whenever you buy it, is it in the worst case? The more you use it, the better it gets. Customized to yourself, and then getting all the latest features. So the automobiles for tomorrow would be based upon the software defined vehicles. I'll give you a quick example. I'll not name the vendor. A vendor sold off some thousands of pieces of a car in different parts of the world, and they realized that probably the performance of this vehicle would become better if we do the ground clearance up by say 3 or 5 mm. Okay, based on all the cars which were being used, because they were able to track those data. So the one way could be that every single car gets back to the workshop, you uplift it with say 3 mm or 5 mm, and then you send it back. If you have a software defined vehicle, you program it tonight, press your enter, tomorrow morning every car gets saluted by 3 or 5 mm. Huge saving. No one needs to go to workshop. and time is money. No one needs to invest time. So that is the kind of future defined, the future definition of the vehicle would be, it would be not a, only hardware. So first shift is internal combustion to electrification. Second shift is from this whole electrification to software defined, where the software is controlling this hardware. And your hardware should be strong enough for the next 10 years, so that if whatsoever kind of software you're going to dump into it, it is able to process that all. Because software anyways, you can keep on, over air, you can keep on dumping me, but you can't change the hardware which you sold out a decade back. So with this, I'm going to rest here. I have another part of whole presentation. I can go for hours, but I was asked to limit it to, the time given. I guess 5 p.m. is something where you want to close. We still have 3 more minutes to go. I'll be happy to answer any questions you have for me. I don't know if there's online option available for audience to ask the questions, but I'll be able to, happy to answer any questions in the room. I know you guys are eager to get this close 5 p.m. push back to your homes. Okay. Or is it? I was told to limit it to the, this time frame. But certainly we can, talk more about, different technological aspects of the car. Because many times I get this question whether it is radar, lidar, or the camera. And I would say a mix of all the three, because all the three have their limitations. All of the three have their, beauty. I would say a beauty part of it, based on the scenario you are in. Because in a fog-filled weather, one of them might not perform the best. But if it is camera, then I get this question: how many? I say the more the merrier. That means we are going to place 100 cameras in the car. Okay, we can do that. Let's assume. But how do you get those 100 feet live coming to some compute, and this compute is processing those whole 100 feet and then taking action before the blink of your eye? Because when you're on road, you don't get, even at times the blink of eye is a big moment. You need to take an instant then and there a decision. Giving an example, typical Indian scenario, there's a big paper or a poly bag in the air, and an autonomous vehicle is coming. Now this vehicle needs to take a call whether there is this object, there is a life in the object or not. It's an object or a human. If I hit this object, does this object gonna harm my windshield because there are humans sitting inside the car? Or if I hit this object, do I gonna put a life at the risk? And then we talk about the other thing, which is focus area of this conference is about the how ethical those decisions could be. Because if you want to, given a condition, if you want to save one life, you need to sacrifice the other life. Then who the other life would be? Based on gender, based on age group, based on the profession this person is in. Certainly. And what if someone is tracking that car all the time? They know that, okay, I started from Bhubaneswar, I'm going to Jagannath Puri, I have parked the park in their parking. We know how many hours it takes to go and do the darshana and drive back to Bhubaneswar. That means the house is safe for next 4 hours. I can easily do whatever I want to do inside this house, even if this information goes out. What if someone from the insurance agency is tracking your way of driving the vehicles? How rash you drive? Do you obey traffic rules or not? Do you wear seatbelt or not? Do you drive in lanes or not? And based on that piece of information, your quantum of assurance would be defined. So those all are the few of the coming questions which we need to solve as a set of engineers. And with this, I'll close my talk here. I'm bang on the time. It's exact 5 p.m.
One or two comments.
Yeah. Yes.
I think you have talked about marvelous, and but the cost of a Mercedes today. I think it is something like 36 crores to 8 crores rupees. The amount of you pay for a BMW headlight is something like 70,000 rupees, white LED. So this cost part of it, actually bothers people to go for this security of the car. Our people are such that in the night they will come and lift it physically and take it away. It's possible. And third thing is, why don't you invent something in the Indian context? I want a car where I can have a toilet, bedroom, and a drawing room inside the car. Maybe it would go up vertically one floor. I use it for sleeping and all that. Come down next day and drive to my office. And the way the cost of the housing is increasing, not less than 2-3 crores for a flat. Why not invent something India centric so that you can live inside a car? I mean, as long as you like individuals.
But that's a very innovative set of question. Let me try to give my
And cars are now
perspective.
available which can fly, which can float in the water. And 3 days back in TV there was a car which didn't have tires. It can crawl on the road with a very high speed.
Certainly, sir. So we have bullet trains, you don't need waves. Use the magnetic field which drives you like a bullet. But coming to your first part, the cost. So my mother used to say, "Jitna good डालोगे उतना मीठा होगा." So the amount of money you pump in, the amount of features you get in. Okay. And even every single car, if you see in the same brand, in the same logo, you'll have L, XL, GXL, some variety. The more features you have, the more money you pay in. Okay. Having said that, there are some standards which are related to safety, security, like airbags are gonna get mandatory, the minimum number of airbags. But there is this market, in particular Indian market, is very cost sensitive. A single airbag getting in, which is increasing your safety requirement, people are not willing to pay. He said, I can live without it. Let's talk about our seat belts. We are still not willing to put seat belts because front seat belt is now made mandatory. Rear seat belts no one wants to plug in.
Clips.
People put clips. My own mother, she's not comfortable sitting in the front seat because she has to wear the belt. She said, "Oh, I'll occupy the back seat." And the day they make it mandatory in the back seat, what? Boot. So, money is certainly, because BMW has the auto park mechanism. In India, we get this. So if you want those features, ultimately there's the R&D cost, there's the, and then everyone is, living at a margin. If I have invented something for 10 rupees, I want to sell it for 20 rupees, making 10 rupees for myself. The other part of it is very good point, sir. You said that, why don't we live in the cars? And we have those big wagons these days. Many of our film stars, they use it. And it is quite a trend in the Western countries. People who go for holiday, they don't prefer, booking 10 hotels in 10 different cities. They'll just pick up that one of those wagon and they are designated parking area. It's not that any street you go and park in India. They have their own parking areas where you have all the luxury. Now going to the vertical side of it is, we used to have double decker in most of the cities in India. I was recently reading, I think in Mumbai they have phased out. It used to be in Delhi and they have phased out now. Yeah. So vertically we can go, but that has to be with the norms compliant with the law of the ground. You're doing it. Certainly can be a good area for someone to live. And I'm not talking. I come across one of this driver. I was getting an early morning drop to the airport, and this guy it was a cold winter morning in Delhi, and I felt he has all the blanket, everything inside the car. And I said, you were sleeping before you came to pick up to me. He said, yes, sir. गाड़ी में सोते हैं. Because they came from some other remote village to the city to make their earning their bread and butter, and they can't afford housing even there. So if someone can live with the present car, then if that car has a little more luxury, certainly you can do it. But that has to be compliant to the local governing laws of the city. And in India, we do have such kind of facility where you have even in the air you have good luxurious bedrooms, everything in the plane. Then on the ground, certainly we can do it. Having said that, that's where we need more innovation. If we have more and more innovation happening locally, we can reduce the bill of material of these vehicles, all these different innovation. As I was mentioning, even if I reduce 50 kg of these wires, that's a huge saving. You save in terms of money, you save in terms of putting this all together, in terms of maintenance, and 50 kg less weight you are, running.
Question. Do you have any plans to go
Wireless in terms of?
I mean, these wires can remove these physical magnets. We have been trying to do it in our science and rocket systems.
No, so wireless communication. So wireless communication is certainly very good, but when we're talking about a huge compute where data has to flow like anything left and right, okay, then every single device I am doing. Now let's assume I have a device size of say 1 mm by 1 mm for one of the semiconductor, and there's another semiconductor of the same size. Presently they are communicating through wire. If I want to do wireless, then I should have a wireless enabled in both of the chips, transceiver. Okay, every single mm I spend on my semiconductor increases my cost.
That's my age.
But as of today, the cost of wire is much cheaper than putting a transceiver in both of these chips. That copper comes cheaper than the transceiver which you need to put in both of these, because ultimately they need to communicate in some protocol. Yeah.
You have experts in communication. Go it through just to digital.
Yeah. No, certainly, if you see, we have this wireless charger now coming in. And a lot of these, infotainment sitting in my car is wireless. But if my whole compute has to be wireless, then everything should have a transceiver. A typical car these days have 1,000 semiconductors. Now, in this 1,000 semiconductors, I want every 1,000 semiconductor to have a transmitter and receiver.
We had a plan to go, say, for example, if you take a GSLV, it has got 300 subsystems over 4 stages, strap-ons. Over SpaceX, you have got so many things for them. We're having some plan, but we don't want to go to Wi-Fi because it can be hacked. Once you are in the air through communication, you are in trouble. So we don't do.
No, so to me, I think the biggest thing which I can think personally on my behalf is cost is the first thing. You will do, sir, one rocket launch in few months or years. Okay. No, still 100. How many millions of cars are sold per day? And if you go and talk to anyone in the purchase of car, you know how they negotiate? They negotiate 5 paisa a component. They said that reduce the cost by 5 paisa for a single component. That's their target every year. So if they are so crucial, because inflation goes up every year and they don't jump in their car prices every year, they negotiate in this paisa and probably cents. If we talk about US market, that's the cost sensitivity of these vehicles, because they have thousands of components. Single screw, you say 5 paisa, how many hundreds of screws you have inside a car? How many thousands of car you're doing in a day? And if you sum of this, this paisa into number of screws, into number of cars, into number of days we are producing this in a year, that makes a huge money. And that's where they negotiate. And here we are talking about increasing the silicon. Silicon is directly money. And we are talking about putting a transceiver on 1,000 chips.
No, don't worry about that.
Yeah.
They are very cheap.
But integrating those transistors in every single technology becomes a challenge. Certainly, okay. So I'll give you a quick example. I think I gave the same example last time I was in Bhubaneswar.
Enough for me to
No,
know
no.
future, immediate future.
Yeah, no, but I'll give you example, sir. I was here in Bhubaneswar exactly a month back in one other location. Sir was there. Okay, I gave that example, and maybe this could be of interest to all the students. They are busy talking in the backside. What if I have the world's best mobile phone invented? All the feature, wireless, satellite communication, never needs to charge, etc., etc., etc. And the weight of that mobile phone is 50 kg. You should have a backpack, and you say that, I have the best phone with me. That's a very good innovation, best of the class in the earth, but not a good product. Because you can't sell it to masses. No one wants to carry a 50 kg mobile phone to the work every day. So certainly we can innovate. Doing a POC with whole wireless chips inside the car, I think is possible. But is my market ready to buy that product? anything in industry you do is ultimately to your dollars. You want the betterment of the community, but not at the cost of your own gross margins. And the moment we see market is ready, because sir is asking reducing the cost, we are asking increasing the silicon. Yeah. Yeah. No, certainly I agree. It's a very good innovation which can be done, but
The cost of electronics.
no, cost of electronics is reducing
Because you are
for the matured nodes. I buy your point.
it will become mature. This many cars, if you want one, let's say, to develop it to much cheaper than other cases.
Sir, I'll give you example. I'm on the recorded line. Probably I'll not be able to talk more. Is that why India as a country was not able to pick up electronics, this electric vehicle, maybe a decade back, and we have our own reasons to it. I'll not say more. I can speak to you offline about it. We have our own reasons why, as a country, we were not able to do it, because there were huge money pumped up by so many good investors. Okay, so it's to any industry, innovation is driven by the market. If we do something which is really innovative, but we can't sell it to masses, then that's of no use to us, because the shareholders would not say, oh, you did good innovation. They are only interested what is the share price. So if it is a market, if our market is ready for such kind of products, everyone wants to do it. And the market comes in pockets. It's not that you get into one product segment for rest of life, you will reap benefits. Gradually there would be a competition and you'll reduce your gross margins. Great. Any last questions? Yes, sir.
Government level, like in our country, government level, any policy, anything has come up for basically driverless car?
Very good question. So the question by sir here is that at the government level, do we have any policy on the driverless cars? I think I'll give you better answer off the record. On the record, I can tell you that I was with our respected minister in a flight from Nagpur to Delhi, and I had the same question to him. And his answer was not that positive as a country. And rest I can
We have
tell you off the mic. I can speak more about it.
fast. Police care afterwards.
Yeah, no, this is huge regulation issue. Then I'll tell you first thing is autonomous vehicle, they need lane driving. First of all, we should have lane marking on our roads, which is not the case. Even if you put lane marking, there's one autonomous vehicle which is going, but every other is a manual vehicle going zigzag. This guy would stop, whether to go left or right.
Why I disable ADAS features in the car.
Yeah.
You don't have any to apply brake.
Certainly.
Not only God doesn't know when the auto will apply brake.
Yeah.
So, what
So there's another good case study I'll tell you.
disable and drive if you want to reach back.
Now I'll give you another case study. There's a typical scenario. This scenario is there that there's a woman on the wheelchair, and she's trying to get hold of a duck which is on the road, and she's going circles. The moment she goes front, the car would know, okay, she's moving forward, but she'll then turn left. The moment you go to left, she'll again come back, because she's trying to get hold of a duck which can go any random direction. And our law is that, okay, anyone can do that. Because typically the roads are meant for the vehicles. For pedestrians, there's a separate path. But we don't respect that diversion. Okay, so with it, I'll take a pause here. Thank you so much for your time, and it was really nice interacting with you. Thank you. I'll exit this meeting.
On behalf of the organizing committee at Centurion University of Technology and Management, I extend our heartfelt gratitude
Yes.
to Shri P. for gracing us
AI
with his
ethics
presence
and
and
its
sharing
social
such
impacts.
profound
The
insights
books are
with us
completely
today. Your words have truly
with
enlightened us
by
and
our
provided deep perspectives
co-editor is Dr. Mari.
that will inspire our academic
Then Dr.
and
Kosik from
professional
UK and
pursuits
third
for
is
years to
Dr.
come.
Mukesh from
Again,
Massachusetts
since
University.
we are a skills
So
university,
in that we are working on one
bringing in industry into
probably this
academia through this
6 to
conference,
5 to 6 months
through
the work.
basically Sri
Same
Yadav
problem.
was of
Our
immense
question is coming to you.
pleasure to us.
The same problem are there, ethics.
So I
Because
also
the rules
would
regulations
request everyone to move for
not in the
the
UK.
tea break
The
at
point is
the
that
lobby.
one is,
And he has
you know,
Exicom
different
members. I
countries,
would
they have
request
different rules,
them to
regulations.
move to the boardroom.
Now, if you take the example of US, within the state, there are different regulations.
And one thing more, say आपके पास में ना ऑटोमेटिक ये बात करें अगर मान लो रेड लाइट्स आ गई कार तो आगे बढ़ गई
We'll be resuming the keynote
Responsibility
session at 5:30.
हाँ, वो कार का
software
बेचने वाला है.
Chandrasekhar, and Sir is Chandrasekhar. He will help you in roaming around the university. Little bit.
Sure, sure. Thank you. Thank
And
you.
we'll be discussing about semiconductor and other things.
Certainly, Chandrasekhar. I need quick, 10 minutes. Sorry for that.
from Aligarh Muslim University. Nalgotia's Institute of Management and Technology, and worked as a professor and director, Noida Institute of Engineering and Technology, Greater Noida. He has served as chair in many conferences and affiliated as member of program committee in many conferences of India and abroad. He has supervised 10 PhD students and many MTech students for their thesis. He has published more than 200 scientific articles, including journal papers, book chapters, and conference papers. So I would like to welcome Professor Dr. Prasad Johri to give a talk on AI ethics and social impact, covering the responsible AI track. Please welcome with a warm round of applause.
Thank you, Sunil. First of all, I would like to thank the conference organizer and especially thanks to Sunny to invite me to deliver a keynote. Before starting my topic, AI ethics and its social impacts, I would like to say something. That I start my research work on software reliability growth model, and just after a year, I shifted on machine learning, deep learning with agriculture and healthcare. So machine learning and deep learning we feel as a tool. So we work on that. But from the last 3 months, I am working very hard on AI ethics and its social impacts with my few colleagues. One is from USA, Professor Mario from Intel, Professor Mukesh Mishra from Massey University, and Dr. Anvi Kaushik from UK. So I'm working very hard on AI ethics and social impact. In a few months, this book will be in the market. So I start to say, this is the. But before starting AI ethics and its social impacts, we must know about the ethics. In daily life, we are always discussing about the ethics. You all, we all people. So what is ethics basically? Ethics is the philosophical study of moral principle, defining what is right, what is wrong in human behavior basically. This is ethics. So now we start with this is the crux of my upcoming books basically. And we divided in the 6 section. Anyone can? So these are we divide the 6 portion. First is introduction. Second is the foundation of AI ethics, social impact of AI. Next is the social risks and challenges, governance framework, and the future directions. So whole book is divided in the 6 section. So first is the introductions. How you define the AI ethics. Next, so ethics is the philosophical study. It is already covered. Next, so AI ethics are the guiding principle that stockholders use to ensure the responsible development and use of AI technology. AI technology, it's required to save human and the environment friendly approach to artificial intelligence. But important question is that why are AI ethics is important? Reason is simply is that the people are working continuously, but nowadays you people are using chat GPT. I'm also using and number of professors are using. We without thinking we just put some notes, 1 and 2 lines, and they are giving the applications fully writing in a particular manner to you. So AI ethics are important because AI technology is meant to augment or replace human intelligence basically. But when technology is designed to replicate human life, the same issues that can could judgment can slip into the technology. Now, these are two best example of AI ethics. First is the Lensa, second is the ChatGPT. With the help of the Lensa, you could create profile using AI trained on digital art. Artists criticize it for using their work without consent, credit, or fair consent. And if the people are using ChatGPT, you could create the text like poem, code, essay, and ethical concern is there because it includes misuse in context, academic dishonesty, and copyright issues. Because we continuously working on ChatGPT without knowing what they are providing to you. So these are the two just most popular example of AI ethics. But what it is really AI is the bias free. No. What can be done to mitigate risk in the future? There are the many potential exits are there, but a stakeholder must act responsibly and collaboratively to create positive outcome across the globe. So what really AI is bias free? So what does it matter? First is avoiding bias, second building trust, third is the protecting privacy and ensuring accountability. These are the 4 points are there if we are working with the AI. So foundation, this is the foundation of AI because we divide in the sections. So AI ethics, then the foundation, after that it's come the history of that. So, but AI ethics is basically it is a good thing. It is a good force that helps mitigate unfair bias, remove barrier to accessibility, and argument creativity among many other benefits. But AI decision that impact the human lives because it's critical that consider the complex ethical implications because misusing of AI. Somewhere there is a minor error of 0.001, it can harm the human life. Just few days back, one incident occurred, one Air Indian plane is go down because of the software error. AI can cause harm to individual as well as the society and the business bottom lines and the reputation. This is the second one, AI historical development and ethics. So it is divided into 3 parts. First, an nascent origin to modern beginner. Second, AI resilience and the ethical challenges. Third, technological advance and ethical implication. So historical fully divided into three parts. So concept of intelligence rooted in ancient myth and the legends. But the modern AI research initiated in the 1950 by Dartmouth Conference, coined by earlier. Early AI research focused on symbolic research and expert system in the 1980s. All people are working on the expert system. Most of the expert system is developed. Rise initial ethical concern about the machine learning decision making, questions potential impacts on human contemporary, and AI winter. It is started from 1970 to 80. It lead to reduce funding and interest in the AI. Temporarily shows ethical discussion surrounding the technology. Second is the AI resurgence and ethical challenges. So it starts from the 1990 and 2000, and we start to work on the machine learning as well as the neural network. But ethical debate are going to be start that it privacy, bias, and societal impact of AI system. Because whenever we are working on the AI, so ethical debates come. Somewhere privacy is losing, somewhere it is not bias free, social impact, and development of deep learning and big data analytics comes in the 2010. It brought forth new ethical challenges related to data privacy, rise concern about algorithm bias, and transparency in the AI decision making process, accountability for AI driven, and fairness of in AI application across the driver population. But the next part is coming, that is the technological development and ethical implications. In that, development of the expert system comes in 1970 to 1980 and lead to discussion about ethical implication of AI assist decision making like medical and as well as the legal reasoning. It come in the picture when Gary Kasparov chess match between IBM Deep Blue. It was the huge big news at that time. It sparked debate about AI surpassing human intelligence in a specific domain. When we are young, then we listen that oh, computer is chess match between the Gary Cross. At that time, Gary Cross was the top chesser. Establishment of organization formline, study AI ethics and experimental tasks. Feature of Humanity Institute, Machine Intelligence Research Institute, and the Google AlphaGo. It defeated the world champion Go player Lee in 2016. It highlighted rapid advancement of AI capability, intensified discussion about ethical implications of AI surpasses human performance in complex tasks. This is the evolution of AI ML from 1950 to 2025. So in the 1950, first industrial AI robot Unlimited. Then comes to after 10 year 1960, there is some revolutions come. Then Jobs developed NLP program. After 10 year in 1970, the ability of machine make decision their own. 1980, companies adopt expert machine learning system to improve business processes. 1990, IBM showcased how AI should solve complex problems. In 2000, an autonomous car by Google with the help of AI and ML is developed. In 2010, market of artificial intelligence experienced exponential growth more than 32 million in the investment. But and now from 2022 to 25, wider uses of AI in financial transaction and personalized shopping experience. Another in most of the things we are using artificial intelligence. This is the principle of ethics. So principle of ethics, there are basically 7 ethics are there. First is the empowering in human building, fairness and inclusion, privacy by design, robustness, safety and security, accountability, transparency, and last is the sustainability. So if someone is asked about the principle of AI ethics, these are the basically 7 ethics are there. Maybe you all are from computer science background, it will come to you in future. So each and everyone, if 7 things are there, so you can say that you are working with the AI ethics principle. So these are the some case studies are there, 2 and 3 case studies are there. In that case study, first case study is on the real world pattern of health inequality and discriminancy. Second is the discriminatory data. Third is the application injustice. And last is the biased AI design and development practice. Here is the work, then data, then design, and then use. That is the things you are, this is the moving. Unequal access and the resources allocations are there. So that discriminancy health care process are there, beside medical decision making there, then the sample bias and the lack of representatives. Next, the pattern of bias and discriminancy backed into the data distributions by using the power imbalance in the agenda setting and problem formulations, biased and exclusively designed model publishing and the testing process. So this is the one of the case study. Second case study with the face recognition method. You people, if you are in the 7th semester or the 5th semester, you people are busy to develop one project or program for the face recognitions. So this is the another case study. Face recognition and hiding biases. You know that they are the figures are there, photo figures. Few, one for men upper side and second downward for the woman, and the cases are from the Malaysia Chinese, Malaysian Malayan, Malaysian Indian, Western, and others respectively. The individual shows it in the figure gave written informed consent to the publications of their pages. So this is the natural expressions used. Each column shows a male and a female face for each group. So facial recognition and hair lead to potential disidentification in law information and the security application, because when you are working with the facial recognitions, then development lower accuracy rate for women and people of color. But in that case, just you see the difference between the male and the female. So there is some biasness out there. So lower accuracy rate for women and people of color. So create injustice outcome for marginalized groups. Second, AI power hiring tool exhibit gender bias. It should not be. Favor male candidate over equally qualified female candidate, particularly prevalent in the male-dominated industry, technology, as well as finance. Language model trained on the biased data set perpetuates societal stereotypes, like reinforce existing prejudices in the generative text. This is another best example of the case study. It will come in my book. So here you are seeing that the data is from South Africa, Senegal, Rwanda, Africa, Europe, Finland, Iceland, and the Sweden. Male and the female, male and the female. Here you are seeing that the example image and the average faces from new pilot parliamentary benchmark. Example shows the images are constrained with the relatively little variation in the pool. Slightly, very low, but the subjects are composed of male and female PPP model from the 6 countries on average. Senegalese subjects are darkness. Slightly darkness is low, and somewhere you feel that darkness is high. So this is another case history for the biasness. So this is the best example, gender study. You can see that study co-authored last year by John Burma, researcher at MTS Media Lab, highlighted inaccuracy in the software from Microsoft, IBM, and the Facebook also, using a control data set represented face called the pilot parliament benchmark. This is the very big issue on that day. Collection of 1,270 front-word photos of international legislators from 3 American, 3 European countries. PPP was selected as a representative area of gender and skin type, used as a control training group, uncovering mitigate algorithms bias through the learned latent structure. So this is the case study how the AI could be biased. Example in the case studies also with the discriminancy, finance and law, as well as in the healthcare department. Bias based on the race, gender, and the super economic studies. If you are going to apply for the loan, so it denies loan to the minority application directly. So there is some biasness there. Offer higher interest rates to certain racial groups. System economic inequalities, predicting policies algorithm, disproportionately target specific demography, focus on low economy and minority neighborhoods, reinforce existing pattern of over-slicing, skin cancer detection of algorithms, performing poorly or darkened skin. So if your skin is dark and highly or like European peoples and the African peoples. So there is the skin cancer reductions algorithm perform poorly on darker skin. Pain assessment tool underestimating pain level in women or certain ethnic group. So these are some example and the case study of bias in artificial intelligence. Social impact of AI. This is the third section. AI is not only the technological advancement, it is a social revolution. It affects how the people live, work, learn, communicate, and govern. Its impacts go for positive as well as in the negative. So positive means that enable progress, efficiency, and accessibility. But also, if we are going for the negative side, so leading to risks such as inequality, bias, and loss of privacy. Social impact. So if we are talking about the social impact is will go to in each and the every area. Like first one is the AI healthcare. Risk is that data privacy. क्योंकि data practical data, practitioner data is too risky. Sensitive medical record vulnerable of hacking, so that the life could be in the danger. Algorithm error. Wrong predictions can lead to harmful treatment. Bias in the training data. Artificial intelligence may perform roles for underrepresented group. Over technology. Doctor may lose critical thinking because they are based on artificial intelligence and software. So they are not thinking critically. But the benefit, AI system, it analyze X-ray, MRI, lab result more quickly than human. AI tailors therapies to individual genetics and lifestyle. Drug discovery, operational efficiency, automate hospital scheduling and reduce paperwork. So these are the benefits, but there is some risk also involved. In employment, automation, job shift. So people are thinking if AI will come, so job will reduce, but new area will open, and that will be more and more. So automation of repetitive job, factory worker, clerical tasks, basic accounting, basically. Emergence of the new roles means that AI ethics officers, data scientists, robot technicians, there are a lot of jobs are in the market, but it's depend on the skill, technically as well as the communication. Workforce reskilling, need for continuous learning, vocational training, and the coding. You all must be trained the coding. You must know how to work on that. Workplace transition, job displacement, anxiety, but also opportunity in innovation. So don't think that AI is coming, so our job we could lose job. Lot of opportunity are coming in the market, but suggest AI could replace at least 20 to 30% of routine job, but also create entirely new industries in the market. Emotional intelligence. This is the another market nowadays. Creativity, leadership remains a nucleus of human skills. AI in law enforcement. Artificial intelligence is now using. Potential benefit is that predictive policies have allocated resources to high crime areas. Recognition assist in identifying suspect. But the major risk is that privacy and harassment, mass surveillance of the citizen movement, bias and discriminancy, misidentification rate higher for minorities and women. Overreach. Government could use artificial surveillance for political representation. Ethical, balancing public safety versus civil liabilities. So, artificial intelligence in law enforcement, risk of surveillance, basically. AI in social media also. Possible solution is that if you are working with the AI, based content modernizations, filter hopeful posts. Fact checking, AI verify claim at real time. Deepfakes, people are continuously seeing and in the daily newspaper just after some time news are coming. So fake videos that appear real. Algorithm amplification, echo chambers reinforce existing belief. Political manipulations, both spreading propaganda at scale with the help of AI. Regulations requiring transparency in recommendation system. But if you are going to develop for the recommendation system, definitely it will hack to you and no one can touch. But you are continuously the people who are working on. So ethical domains in artificial intelligence. These, if you are working with the AI ethics domain, first is the algorithm bias. Second is the self-driving car, lethal autonomous weapons, unemployment and income equalities, surveillance practice limiting privacy, manipulations of human judgment also. If we are working, then misuse of generative AI, copyright and ambiguity, because we are working with ChatGPT and others, trustfulness and accuracy, robot ethics, artificial general intelligence, and proliferations of deepfakes video. So these are some ethical dilemma in AI decision making. It means that there are some confusions out there. So people are in that. So next is the accountability and responsibility in AI system. Robustness, privacy in data protection, fairness, transparency, accountability, and trust. It means that the relationship between the accountability and other component of the responsibility, because it is responsible. So if we are working with the AI developer, organizer, stakeholder to ensure that AI system operate ethically, legally, and transparently. It involves mechanisms that enable AI decision making to be monitored, explained, challenges when necessary. This is the best example, or you can say the case study. So this is the situation of self-driving car. Just before me, Dr. Yadav was there, he was discussing on that. Self-driving car that failed to stop a red light, causing an accident. So this situation highlights an accountability gap in AI, where it is unclear who is responsible basically. Whether the fault lies with the AI software, car hardware, or outdated data. Because if the outdated data will be there, software will be corrupt, or any of the hardware, so the accident will be there. So to address this gap, through investigation is needed to pinpoint the cause of the error. Result of this investigation must be transparent, shared publicly, followed by corrective actions to prevent future incidents. This approach not only fill the accountability gap, but also showcase the importance of clear responsibility of artificial intelligence system. So this is the best case study of biasness, accountability, who will be accountable and responsible. Next is the security risk, that is the adversarial attacks. You always listen that the cyber fraud is there, so it means there is some attack is there. So AI, known as the adversarial attack of AI system, it is a fact of machine learning that involve malicious actors deliberating attempt to subvert functions AI system. I chose the example, not showing that this one. Example is this one, adversarial attack. Just you see in that diagram, attacker training the data, AI system model. So attack is going from the different part. So AI supply chain attack, backdoor attacks, distributed denial of services, or data poisoning, model skewing, and transfer learning is there. So that safe risk, privacy concern, security breaches, misinformation spread, resources drawn, and expert poison content indirectly promote injections to the your system. So this is the all AI users if data is not trained. Security risk in the AI pipeline. It is divided into two parts. First is the design, second is the build and run. Data collection and handling. So there is the storage of AI model and training and the featuring the data. Model training, workload and tool for training, system architecture, and the model inference. So prompt injections are there, model extractions are there, overbilling the model, untrained cross the data, explore the training system, and data poisoning basically. So these are the security risks in the AI pipeline, but it works in the two ways. First for the design, second for the build and run. Deepfake information. You people are continuously listening about the fake news. So misinformation, disinformation are commonly known as fake news. The mis and the disinformation phenomena has been catalyzed by technological revolution, increasingly frequent use of the social media contribution, by the amount of data shared or processed by algorithms. It has also changed the way news is created and disseminated. But information is sharing of incorrect information, where information is the share of incorrect information. So example is this: defect, then it goes to misinformation. If no, then there is no impact. Content authenticity, that it is verified, trust sources and the information inform audience. Otherwise, not verified, use caution and goes to the informant. But if the misinformation is there, yes, then it goes to the spread misinformation, public confusion, then trust is issues, media responsibility, and last is the fact checking initiative. So by this way, the people are, there are the some defects and the misinformation portion. So this is the, again, what are the defects used for? Defect used for election manipulations. Continuously, people are busy to target someone. Social engineering, automated disinformation attack, identify theft, financial fraud, scams and hoaxes, and celebrity pornography. So defects and the misinformations, these are used basically. Again, defects and the misinformation. This is a real case study. 73-year-old man named Radhakrishnan reviewed on WhatsApp call from someone who appeared to his former colleague Venukumar. This is the real case study. It is also on the internet. You can see the caller using defect technology perfectly mimicked Venukumar voice and appearance. Caller asked Radhakrishnan for a loan of 40,000, claiming that he was in the urgent need of money. Believing that the caller was indeed his former colleague, Radhakrishnan transferred the money without hesitation. So there is a fraud. Another example is there. UK-based energy company fell victim to a sophisticated deepfake audio track that resulted in the loss of $2,43,000. According to the trained macro attacker, used AI to clone the voice of the company CEO, impersonate him over a phone call. The frustrated mimicking the CEO voice with near perfect accuracy, instructed and company finance director to urgently transfer fund to Hungarian supply. So this is the problem. Only after the funds were transferred did the company realize that the call was a deepfake, and the real CEO has no knowledge of transactions. The money was immediately sent to a series of bank accounts in different countries, making it impossible to recover. This incident highlighted how defect technology can be weaponized by bypasses traditional trust mechanisms and trigger large-scale financial fraud. So this is another case study how the deepfakes and the misinformation can cause a lot of money. Deepfake scheme in the Hong Kong also. Same, the 25 million to a fraud account, believing it is a part of an urgent business transaction. The UK case study, deepfake technology was so convenient that the senior executive had no reason to doubt legitimacy of the call. By the time the fraud was discovered, the fund has been transferred through multiple offshore accounts, making recovery impossible. Whenever fund is transferred, they immediately transfer in a different account. So it is impossible to return back. So there is a next section, governance and framework. AI regulations, current global approaches. European, EU AI Act is there. What first comprehensive AI law is in the Europe? Risk-based, ban unacceptable AI, regulates high-risk users, biometrics, healthcare, and hiring, lighter rules for low-risk AI. is strong on human rights, accountability, and transparency. But in case of United States, no single federal AI law is there. AI Bill of Right, NIST at risk of framework, light touch, innovation first approach. But there is some rules for healthcare, finance, and defense. But in the China, it is strict and centralized regulations. Generative AI rule content moderation, security checks, source transparency. Algorithm must be restricted with the government, focus on national security, social stability, and state oversight. But United Kingdom, there is no standalone AI law. It uses existing regulator. Pro-invention, flexible approach. India, no dedicated artificial intelligence law yet. Approaches enable not regular. Publish national strategy for AI. Focus on AI healthcare, agriculture, education, and smart city. Exploring rules on AI safety, transparency, and accountability. But still there is no law. To adopt balanced approach, encouraging innovations while adding safeguard gracefully. Other countries like Canada, Japan, Brazil, they have working on ADA, Society 5.0 and other, drafting AI framework. Roles of government in AI ethics. Government are centrally to creating some rules, standard, accountability system for AI. So their role include policy regulations, drafting law, setting risk-based framework, standard and guidelines, publishing principle for fairness, creating national strategy like India's Niti Aayog, oversight and enforcement, establishing regulatory bodies to monitor complaints, impossible penalties for unethical or illegal AI use, public sector use artificial intelligence, government themselves must use AI responsibly in policies, healthcare, and other services. International cooperation, working with the UN, G20, OECD on global AI forum, sharing the best practices across border. So non and role of NGOs and ethics, awareness and advocacy, research and ethical guidance, watching role, capacity building education, global collaboration. This is the role of NGO. And last is the future direction, responsible of AI development. This is the roadmap. Choosing the right problem, clinical relevance, appropriate data, collaborator, defining of success, then developing a useful solutions, data governance, ground truth, then comes to considering the ethical implication, ethical engagement, bias correction, then the rigorous evaluations and thoughtful reporting like model use, essential predictions, shared model, failure modes, then comes to developing responsibly, prospective performance, clinical trial, safety monitoring, and last is the making it to market, medical devices and as well as the model update. So this is the responsible AI development roadmap from start to end. This is the human-centered AI framework. Define AI-enabled capabilities. Objective must be clear, stakeholder must be clear, and user need project constraint and areas where AI can add values. Align user need to data input. This is the most important. Why? Align user needs to attainable data input and developing an on AI model. So data and aligning is the most important. Next is the ideate AI enabled opportunity. Brainstorm sessions. Generate ideas for new design, possibility enabled by AI capabilities. Explain product feature to user. Explain inner working of AI model and communicate what AI does for user to promote user. Impact of technology on society. measure the real world outcomes, benefit, implication of the AI solution, and iterate to improve. This is the emerging technology of ethical implications in near future. First one, knowledge from information system supporting AI infrastructure and event log, then identify accessing the impact of safety, security, and privacy. Then comes to the ethical and the legal implications that autonomous vehicle must follow for decision making. Then comes to the complexity related, take the right decision in a certain time frame, and vehicle automation system cannot guarantee that the decision made by the system in a time bound frame considered all measure on matrices related to safety, security, regularity, and ethical code of conduct. This is the emerging technology and ethical implications. Conclusion in the last is the call to action. AI is the transforming society economically in everyday life. While it is potential for progress, it enormous healthcare breakthrough the sustainable development. It also carries a risk of bias, inequality, surveillance, and loss of human agency if left unchecked. Ethical and the socially responsible of AI is not just technology challenges, but a governance and a value challenge. So balance must be struck. Innovation should be encouraged, but not at the expense of the human rights, fairness, and trust. Government, companies, NGO, and citizens all this shares responsibility of shaping AI that align with the human dignity and common good. So these are the call to action: government, then companies, developers, then NGO, academia, global and collaboration, and cities. So final message is that AI should not be smart. It must also be ethical, inclusive, human-centered. Together, we must ensure that AI strengthens societies, protect freedom, and deliver positive social impact for generations to come. This is the final message. Thank you. If you have any doubt, this book will come in near future within the 6 months and the second. So this is the cracks. So books is divided in 6 sections. Introduction, then foundation of ethics, social impact of AI, risks and challenges, governance and framework, and future directions. So most probably 3 volumes will come of this. In each volume around 20 chapters. Any questions you could ask? But you must work very hard. There's a lot of jobs in the market, but they want you must be strong technically as well as if you have both, you could get job. Data structure, SQL, and one language. Not to go for 10 languages, one language. Okay, thank you.
I would like to thank Professor Prashant Johari for his valuable insights on responsible AI, which was a track of our conference. And next with us will be Abhishek Agrawal of Amazon. He will be connecting with us virtually because he is at Seattle, US. So Abhishek Agrawal is a seasoned engineering leader and senior IEEE member with 2 decades of expertise in artificial intelligence, data science, and analytics. He is currently spearheading a critical AI initiative at Amazon as a software engineering manager aimed at enhancing the quality of the company's product catalog using generative AI and large language models. And along with him will be joining Praveen Gupta Sankar of Meta, who is currently working at Meta. So he is an accomplished data scientist with a decade of experience in analytics. He has contributed to industry-leading organizations such as Amazon and Meta, where he tackled complex business challenges and championed data-driven decision-making. His expertise encompasses machine learning, statistics, and scalable analytics, enabling him to drive the launch of multiple groundbreaking products. All the participants who are here, so let me tell you that today's AI is democratic. Democratic in the sense it is for all. It is not for computer science only. So I would request our virtual speakers, over to you. Abhishek ji, are you there? Mute, unmute. Make him a co-host. Praveen Gupta. Yeah, make him a co-host. Confirm. Unmute him. Abhishek Agarwal. Please unmute. Abhishek Agarwal. Yeah. Abhishek ji, Praveen ji, over to you. Thank you.
Thank you. Thank you, Sanjeev, for the introduction. Myself, Abhishek, as the introduction is already called out. And Praveen is joining me in conducting this workshop. Sorry, it's very early for us. It's 6 a.m. We are still in pajamas and giving you this workshop. Hopefully, we will make it count for you. Without delaying further, I'm just going to start sharing my screen and giving you a quick overview of what we're going to cover in this. So we have conducted this workshop. Let me know if you're able to see my screen. Yeah, so we have conducted this workshop at IEEE section, Seattle section as well, and it's a refined version of that we are sharing here. We are also conducting this workshop in Seattle AI Week, and see if we get accepted in ACM Cyprus conference. Anyway, so this workshop is basically it's a hands-on workshop for you to conduct create an AI agent from scratch. We wanted to reduce the barrier for anyone to create an agent. So we have created this workshop so that anybody with minimal coding experience can create it. To follow along, if you have a laptop, that will be the best. I'm going to share a link of a notebook that you can clone and can get going with our presentation. Along with, you can exercise that notebook, clone the notebook and exercise that for yourself. So here is the link that I'm sharing with all the participants. And I'm going to please clone this while we go into the abstract and things like that. So, yeah. Great. So I think introductions are all done. We will skip the logistic because I think it's just about an hour or 2 hours for us to give you a walkthrough of the code as well as run it with you. But anyway, we'll cover the agenda. What is the LLM versus agents? Different tools, agentic framework. Then we will walk you through, if not allow you to work with us in this session. We will have a YouTube video summarizer agent and then study planner agent that will walk you through how you can go ahead and do it for yourself and then enhance it for your needs later. So with that, just wanted to start the discussion and then wanted to see whether if you have an opinion on what is ChatGPT, is it a large language model? Is it generative AI application? Is it an agent? Any other guesses? If you have an answer, great. Let's just go over this. It's a generative AI application built on top of the large language model that has a basic agentic capabilities, and they are enhancing these capabilities on a daily basis. So you will be seeing those enhancements like integration with Word, with Excel, and all that. So these are all other agentic capabilities that they're developing. Some clarification on the buzzword, LLM versus generative AI versus agent. So let's just demystify them a little bit. A large language model is a deep learning model trained on a vast text data to understand and predict language. Generative AI, AI application that creates new content, text, images based on a learned pattern. And the agents are an autonomous system that takes action, interact with tools, and can perceive goals. And we will go to the formal definition of agent shortly. Um, I'm just going to skip over a lot of the details we thought we'll cover given the short amount of time, but very briefly, at the core of an agent is a reasoning LLM model. Generally, an LLM model, and it could be any reasoning model. Maybe we have right now, and maybe something that will may come later. And given the most of the development of the large language models and artificial intelligence happened on the neural networks, we are expecting a neural network, powerful neural network model supporting the agent, which provides the model the reasoning capability that the agent performs its actions, understand the world that we wanted to, or the task we wanted to perform. Um, Neural networks are often a many layer deep, which means, hence the name deep learning. And I think their power lies in the number of neurons or which supports them. And that is what allows them to have some level of reasoning capability. Human brain continue to be a very sophisticated system, but AI is catching up. Anyway, I think these details are more on helping you understand a lot about the large language models. And I can potentially give you a quick brief about this. Uh, for any large language model to understand the world, there are multiple layers. And I think in ChatGPT or the GPT-3 model, there are around 175 billion neurons, and they are, I think, if I, Praveen, do you remember number of layers that it has?
Not off the top of my head.
Yeah. So, but anyway, so basically, it is a classification model. All it is trying to do is given a token, trying to predict what is next token. That is a basic setup for the any GPT model. And based on that, they make a lot of prediction, which goes through multiple round of revalidation before a final output is detected. So in this particular case, what's happening is the model is trying to predict whether it's a cat, a dog, or bird, and it is just giving different probabilities. This is simple network, and now you can think of large language model being similar version. All that it is doing is trying to predict the next token in this string. Um, this is typical setup of any neural network. They have multiple nodes, and there are inputs to the nodes, and there are outputs from those nodes that goes to the next stage, and ultimately a final output get emitted. So yeah, I think this is the same thing I was saying. Uh, this is the classification problem that large language models try to solve repeatedly. And this is how, so it gives an abstract, it gives an impression that it understands the language, it has reasoning capabilities, but all it is doing is based on its training data, it is trying to give you the next best guess of this token, and it is constructing. That's why you will see large language models when you interact with them, chat GPT or any other thing, it goes very slowly because it is doing a repeated calculation and trying to predict the next token given the string that is already produced. And that is why there is a concept of a context window that it can support. Most of them are on 128 kb, and there are sophisticated models that can support larger models, a larger context window. So I think the training data, I think, is the most important. And what's happening in the agentic framework, that a general purpose, intelligent, knowledgeable agent um, is still not specialized enough for us to use on a daily basis because of the hallucination problem. And I'll come to that. But they are trained on a variety of data. Each input gets converted to numbers. This is internals of how LLMs you can think of. Large number of matrix multiplication happens, and ultimately model convert number to a response. LLM is predicting the next token in a large response at a time, and that explains why LLM works slowly. Um, these are some of the models that you might have seen, and there are newer models that are available. We'll run through those. I think this is the, in the context of agent, understanding what LLM is, not what it can or cannot do, is a fundamental understanding that everybody should carry, because then you can imply or apply the agent in the right way. For example, an LLM is a predictive engine that pulls patterns together based on a pre-existing text to produce a more text. It doesn't understand the language of math. So if you get an impression that it understands English, maybe that's the impression it is creating, but it is based on the training data and huge amount of training data that it is able to predict what is the right next token. LLM does not understand modes of information retrieval and creating writing. It's simply predicting the next and most probable token, and it is highly biased towards the training data that was supplied. Does it understand emotional effects? No, it has no understanding unless training data contains something about the ethics. If there are training input about text, that okay, this is immoral, then it will understand this is immoral. When you ask in the context, then it will be able to tell you that yeah, it seems something there. So it is able to recall very efficiently whatever training was supplied to it and able to produce the next token for you. So it does not understand ethics. It is up to the framework around the LLM that it can build and give you that purpose. If you are interested, there is an open Git repo which contains all the large language models that are available. But let's get into right into the middle of our thing. What is the agent? Since I'm not able to open up for question and answer, otherwise would have loved to have an introduction here. But let's go over what is an agent. This is the definition that was accepted by Google, and there are multiple definitions of agent. So you may come across multiple of those, but we are using the definition which makes sense for us, and that is generally accepted by the uh, different companies at this moment. AI agents are systems that can perform tasks autonomously by interpreting data from environment, making decisions based on that data and executing action to achieve set goals. They operate under predefined algorithms and machine learning models that enable them to learn and adapt over time. And what differentiates them is their autonomy. I think that is the key of uh, the power that comes to any software. Because so far we've seen only software which are coded for a specific purpose and they can do that work. But when it comes to deal with novel situations, the traditional software seems to fail and they cannot handle those situations. So we have a lot of error handling in the current software. That is what agent is set to change. And they can operate in a novel situation based on their reasoning capability that they might have developed based on the training data that was given to them. And then any specialized LLM, which are specialized for a specific domain, might have a lot of reasoning capability within a domain to take an autonomous decision. They can react to their environment based on the responses from either other agents or the user or other input sources. They can take proactivity, ability to communicate with other agents and humans because of they can reason through the humans' input. So in a basic agent, there is an orchestration powered by an AI model. It has a set of functions. It has some memory. That is what we call it over context, and that would be, and that is a limitation right now. Um, and then there are external tools, and you can substantiate this memory by storing data, and these frameworks that develop those agents can provide you that additional memory. And these agents interact with the external tools to accomplish the output or the task that you want them to do. So this is a basic definition of an agent, and there are multiple of those. So if you come across many, don't. It is one of those more acceptable. So, Praveen, do you want to cover some of these slides? Why agents are powerful?
Yeah, I can do that. So, can I share my screen? I think the next part also I would need that. So, do that.
You are also the co-host, sir. You can share the screen.
Okay. Okay, awesome. Thank you. Thank you everyone for this opportunity. Give me 1 minute while I see. Okay. So very quickly, like we'll show in creation of an agent, right? Like till now we discussed about some theoretical stuff, like what is going behind an agent, like what is an LLM, how LLM is helping an agent. Let's quickly jump in and see how agents are in action, right? So I hope some of you have cloned this notebook. This is the notebook that Abhishek shared earlier. It has like all the instructions on how to get things done. Like we have like a couple of three problem use cases that we are solving in this notebook. We'll start with the first thing, right? Like YouTube summarizer agent. Um, so the idea is you give a YouTube link and it's going to tell you what the summary of the video is, right? So how do we develop an agent for that? So this is a very simple use case, like where you are not integrating with any tools yet. I mean, there is a tool that you're using, it's YouTube tools. It's not like as an agent, you are not enforcing the other thing to do anything. You are just summarizing information from from a source. So these are some of the packages that we need to run our workshop. So we use Google Colab secret keys. So how to get Graph API key, OpenAI API key, all the instructions are right here and at the bottom of the this notebook. So we are using something called Graph. It's a model hosting platform. Basically, like all these large language models, they are super expensive. Like it's you'll not be able to run them on a simple like CPU machine. It requires GPUs and and depending on like the number of uh, neurons or like how deep it is. Like Abhishek was talking about the number of parameters of the model, right? So depending on the size of it, like we might require like multiple GPUs. So instead of us like running these large language models on our own local machine, we can run on Grok model hosting platform uh, through this API. So we have an API key we get. So we trigger like the model that we want through this key. And Grok has a bunch of models. Again, some of the resources are at the bottom of this notebook. Like you'll be able to access like Llama and like I think GPT and a few other models as well. So let's jump in, right? So we're using something called as a Phi data as a agentic AI framework, which we'll get into more details, like what agentic AI framework is, what are the other options that we have. And let me first show you like the output, right? Like what it is able to do. So we are asking to summarize a video. So this is a video of like Andrew Ng like teaching the machine learning specialization course. So you see, this is the uh, like it accurately captured like what this. Let me give another try.
Yeah. So just wanted to cover a little bit on this one. It is using YouTube API. So we use YouTube tools. If you look at, maybe just give you a little bit of dive deep into this agent. So PyData is a agentic framework which allows orchestration to different models. So it is running the model on Grok. It is calling the API of Grok to using the prompt that we have given. Then it is using the YouTube tools to call a YouTube API to understand what the video content are. So there are description about this video, there are comments on those videos, and there could be additional information that it might be retrieving from the video to create this summary for you. So here, what we are doing, we are giving it that which model of Grok and Llama you are going to use. We are telling what tools to use, and you can give more tools to it. And we have made debugging mode off here, but you can choose to give that model. And here we are giving it's a description which it also uses in which is basically a prompt that we are giving it. And that is what characterize what this agent is supposed to do. You can change this prompt a little bit and then or change it completely, and you will see a different output from this.
Yeah, and this is a prompt for setting up the context, and this is like a prompt like what we want the agent to do. As Abhishek rightly called out, right? Like in this, like connecting back to this chat, like AI agent, like the our Phi data, like what we are triggering is the orchestrator. We're using a model. We just discussed some functions, which is the like the tools like YouTube tools here. And in our next workshop, like the next part of the workshop, we'll show uh, how to integrate with other tools. And then like it has some memory aspect, like if we are like having like multiple back and forth messages like to this particular chat agent.
Yeah, just wanted to share a little bit, Praveen, if you can turn off the debug mode off.
Yeah.
And then walk them through. So then it will give them the internals of what agent is doing, and then you can jump onto the planner, study planner agent.
Yes, yes. I just rerun the cell with the debug mode set to true. Like, so you can see like all the things that are happening here. So it's making two calls, like it's getting like, video data and video captions. Again, these are like, some of the functions are tools written by PyData. Uh, like this
You
LLM
can even
is
show
able
that the
to,
YouTube tools, like what all the APIs that are available in the tools in the file. If you want.
right.
Here is the API that that PyData YouTube tools has, and we can go over.
Yeah, so here you can see the functions like get video data and get video, get YouTube video data, get YouTube video captions. So what it is doing is, based on this text, it understood that there is a need for it to reach out to YouTube tools. Like again, when I say it, like it's basically the brain, right? Like the first thing that this agent does is like understand the question, like uh, using this model that we pass as input, and then with that question in mind, it looks for like all the tools that are available, and because we are asking about summarizing, the model is able to understand that I think we should get like the video data and video captions, and then we can run a summary. Like it's breaking down those actions internally, and then once we have the output, again the output is passed to LLM, which is then summarizing information for us. That's the final output that we are seeing here. That's the final output you are able to see here. And you can see like it's saying like unable to retrieve the captions, so which means like they will get YouTube video captions did not work for some reason. But yeah, so whatever we are getting here is coming from like a YouTube video data like function. And I think we are getting into like some of the nitty-gritty details, which I think could be useful. Yeah. Anything else that you want to add on this, Abhishek, before I move on?
No, I think I'm not able to see the screen on the presentation because it's very.
Or is it like, how about others? Like others are able to see the screen?
It is on the, I think on the video, they're projecting the screen, so I'm not sure which portion is being shown, but I think, yeah, this covers majority of whatever I wanted to convey in the first part of this.
Okay.
Yeah.
Yeah. So yeah, I mean, we looked at all these things, right? Like we see like AI agent is able to like do multiple steps of actions here without us actually telling, like through API calls, like uh, doing something, right? Like, so what is actually making this AI agent so powerful, right? So it's this reasoning capability. Like you give a, like writing, summarize the YouTube video, I can write something else, right? Like I can write like describe the video, and still it's going to give me a similar output. Like it can still understand like the meaning behind those words, in the sense like it's breaking down like what actions needs to be taken based on the language input that's needed. So I think like the reasoning capability is the one that makes the AI agents the most powerful. um, Abhishek, do you want to quickly cover this one? Like the world today and world tomorrow, like why agents are going to the future. You're muted.
Yeah, thanks. Yeah, I think what's happening in there are, if you look at so far, all the websites, all the applications were built assuming a specific framework that user will interact with the applications. So they have predefined user interfaces. They have a lot of large UI model, UI designs before they release any software. That was, and there was a lot of user studies that get conducted. So the mode of interaction primarily of a software application with humans happen to be those the UI interfaces. Now with ChatGPT, that if you would have seen that interaction has completely changed. All it gives you, ask you what you want to accomplish in a text box. You give your requirements in that, and it gives you everything that you need. And the things are enhancing on presentation. So the inputs are now uh, inputs are becoming one. So if you think of, there will be a huge simplification of various websites. You don't have to find out, oh, where is the sign up, for example. How can I uh, sign up for this website, or where I can process my payment? You have to look for those elements, and those may be simplified. You can just go to a website and think of, oh, I want to make a payment, and then website will give you a link that you can click, or you can give your card information, and you will be able to enter, and it may be already there in your profile, and it might be integrated with ChatGPT, and you can say make a payment to say utilities department, and it you can even use even further, where you can automatically make those payments and allow your agent to make those calls unless you make the payment um, uh, or monthly expenditure if it is not beyond. So those kind of smartness will start creeping into all your applications, and it will also simplify the UX designs to a large degree, because interactions will be it will be through a human centric point of view, where people can express themselves in whatever way, and the most appropriate content get available. So that's why you will see a very dramatic change in how applications are written over the next period of 2 years or 3 years. And given the power it gives for the users, uh, we believe the agents are the future. That's why every company, whether it's Microsoft, Amazon, Facebook, or Meta, Google, everybody is investing in the world tomorrow, which is the agentic AI frameworks and the infrastructure. All the clouds now, agentic first framework, they're investing a lot in making them agent friendly, so you can deploy your agent, you can run your agents and power a website. And it's not saying that your websites will go away, but they will dramatically simplify. They will provide much more powerful functionality at much lower cost. Um, so that's what I wanted to cover here.
Yeah. So let's talk about like few applications of agent, right? Like the first one that distinguishes AI applications over the current applications is their ability to reasoning. Like that's the, we already discussed this. This is the key aspect that distinguishes AI. So whether it like ranging it from like what stocks to invest, like to the buy bike that you want to buy for a kid. Now, the reasoning is an important capability, and through AI, like we're able to master this. Through LLMs, we're able to master this. So moving to the next one, like its ability to integrate with other apps and build automations. So, for example, let's say you're going on like out of office, and then you want to cancel all the meetings when you're out of office. You can do that in a single click. You don't need to actually go to every meeting and do the cancellation thing. You can do in a single click and saying, uh, like move all my meetings to whenever I'm available next time, and then it's going to move all the things. And then the script can be like different as well, and that's what makes AI unique, right? Like you're not creating a tool, you're creating an interface, and you can interact the way you want it's going to still do the job for you or the action that's needed for you. We're going to briefly discuss about like our integration with Jira tools on how like we can achieve the automation through the tool integration. And then yeah, you probably must already be using like scheduling and planning again. Reasoning is the key thing here, and then conversational interface where the memory is required, right? Like in order for anything like to be a coach, it requires like to know the personalization of the context, historical context, and that memory will help like these agents like uh, to be better at the conversational interfaces. Yeah, we talked about a bunch about like LLMs, AI agents. We looked at an example of how a agent like actually is working. We talked about a package called PhiData. We were using that to create the AI agent. What is actually PhiData? It's a agentic AI framework, right? So there are a bunch of frameworks out there. Like to give you a brief description of what it is, it's a toolkit that helps in the creation of AI system access. Uh, for example, like I was showing, like in PyData, these are all the different tools that you have access to. Right? So you'll be able to like access DuckDuckGo search engine or your Google Calendar, like, and you are able to perform a few functions through accessing those tools, and they make it native to that framework, and that's why it's called framework. So what are the capabilities of the agentic AI framework? Like, why do we need them, right? Like, the top thing that I would say is the tool use. Like, the as you have like more number of tools that are present for that particular framework, you'll be able to accomplish more number of things. Like you'll be able to integrate with more number of integrate and connect with more number of external tools and get things going. The multi-step reasoning part, it's coming from LLM, right? Like the LLM that you like that it can have access to will be the key to this part. And then memory discusses about like the short term or like the persistent memory it require like it will use to answer your questions. Then agentic AI framework can also have like multiple agents in place. Let's say you're planning to book a trip. You can have like a hotel search agent, flight search agent, and then because hotels could be cheaper on some days and flights could be cheaper on some other days. Like how exactly a travel agent would do, right? Like they'll suggest you different options. So that's exactly what agentic AI framework should also be able to deliver, which means that different agents needs to talk to each other, and that's what the frameworks will help to deliver. And then ultimately, like UI integration, like as there is UI integration for the agentic AI framework, there will be like more adoption likely. We discussed briefly about like models and tools that uh, agentic framework have access to that determines the power of the agentic AI framework. Here are a bunch of models and tools that this PyData framework has access to. These are some sample lists that I just pulled. You can visit their website and see like what other things are available. I'm sure like similar set of tools models will be available in like other framework too. And like once you know how to use this framework, it's like it's going to be similar on how you would replicate things in similar in other frameworks. Okay, let's quickly jump into the second part of the workshop, wherein we're going to discuss how like this agent is going to integrate with the external tools, right? Like Jira. So our second tutorial is about a steady planner agent. Like it can create a personalized steady schedules based on user input and like the timelines that they and then like once it creates a schedule, it can automatically push like tasks to Jira. Jira is a project management tool. Like a lot of software companies use this. I'm integrating for this use case to show like the power of agentic AI framework, right? Like how like a simple prompt like I want to learn machine learning and I know basics. I have like 2 weeks to learn. I can spend 2 hours daily. Create one task per day in Jira. Like how a simple prompt like this can create like all the like different tasks, right? Like I'm sure like a plan from various LLMs, like even like with GPT directly or like with other chat agents. But like integrating is something we are talking as a power of the agentic AFML. So we want to show that part to you. So like again, so we are using Grok, which is the model hosting. So not getting into the details, and then Jira. So in order for this notebook, whatever we are seeing here, to create a task in Jira, it needs to have access to the Jira account, to my Jira account. So we need to provide like the username and the API key as input. Just quickly run this.
Let me just cover a little bit here.
Yeah.
So basically, Grok API is still going to be for the invocation of the model, and Jira token is also the key that is needed for accessing calling any API. Other things that you see, the server URL, the username, these are used by the tool themselves to identify the right URL, because these platforms supports multiple users, so they need to identify the right URL. And if you see in this study planner agent, all we are supplying it multiple tools. So you can supply multiple tools. You can write your own custom tools if required to achieve the work. So yeah, that is the key here. And in the in you can supply here. Additionally, we are using instructions, which is what we have not used in the previous simpler agent. But in this case, we are also using instructions, which are becoming part of the prompt, but it intelligently masses the the task that we're giving in terms of uh, the ask that we want this agent to do. It includes those instructions and supply it to the LLM model, which then come back, tell us how to execute that plan, and then the framework execute the plan, give you the response, and in that response, it is creating all those the tasks.
Yeah. Great points. Uh, So in this code, now what it is doing, let's give a brief overview, right? Like, so there is this project called test, like in my Jira account. It currently does not have like any tasks yet, right? But when I run this code, like the code is automatically going to create tasks in my Jira account, right? So what it is doing internally, it's it's doing some Google search, getting like what are the like relevant search results for like the tutorials or like blogs, like how someone can learn like machine learning, like given these are the inputs. Then it uh, that it has like they have 2 weeks and they can spend 2 hours, so it breaks down like bite-sized tasks. And then because we are also asking it to create like a Jira task, so it is going to integrate like it's going to interact with this Jira Tools API and then create a task. So let's quickly see how things are going to be in action. Right, so here it's running. Um, Okay, you can see that these tasks are getting created as we speak. So we'll get like 14 tasks that needs to happen, right? So because we asked it for like 2 weeks. Uh, there you go. We got like 14 tasks. And all of this is happening in a single prompt, right? Like uh, in a previous world, what we would have to do is like you have to like Google says like identify a plan, like break it down. We would have need to like manually put like a Jira task like manually. All of that is automated. I don't even know how to like. I'm not even invoking Jira API on my own. All of this is done behind the screen, like through the agentic AI framework with the help of this LLM. We can even take it to the next extent, like where we integrate with the calendar API and like get like calendar invites on our calendar. And this is the extension which will not get into details because of the interest of time. But technically, like you can integrate it with as many tools as possible, right? Like and automate things. Like I would say AI agent is more like as we already previously called it, is more like a orchestration, right? Like you have LLM, it's a tool in your box. Now you use this LLM to solve like multiple automation things by integrating with different APIs, right? So yeah. That and then yeah, so we discussed like bunch of benefits and how the agents are working. Let's also talk about the challenges, right? So like the top most challenge that I want to call out is that the consistency is not guaranteed in a for LLMs, right? Like or for the agents, because LLMs response vary across runs even with identical outputs. If I run the same YouTube summarizer agent again with exactly the same things, it's still going to be a different output, because all of these models are probabilistic in nature behind the screen. Every time, like it totally depends on the input seeds that it goes with, like for that particular run. So yeah, it naturally becomes like hard to debug like why certain things happen in a certain way. And like we have till date we have acting with systems where consistency is the key, right? Like you interact with your computer system or like your calculator or pick any software system. Consistency is always the key. Like you give an input, it always gives you some output that's a function of that input, but the function itself keeps changing in the LLM or with the use of agents, and that I would say is a challenge. Um, and it is highly influenced by prompts. Like we are saying like even if the prompt is not changing, the output can change. But if the prompt changes even slightly, the output can even change to a much larger extent, right? So and we're also giving the user autonomy, right? Like users can type in or interact in their own natural language, and we should still be able to distill the information from user's prompt and get like the required output. Uh, so while that is there, like as a part of providing the capability, it's obviously like also get influenced by prompt. And the topmost thing I would want to call out is the hallucination, right? Like um, sometimes it can confidently tell, like the LLMs or agents can confidently does tasks for you which are incorrect or it's based on some fabricated information. Now, for example, like if I ask it to create like 14 tasks, what if it creates 50 tasks, right? Because all of this is based on some inputs, and you have like 50 numbers somewhere in your prompt, and it incorrectly interpreted and created 50 tasks. Yeah, so it's uh, it's often bad, and to make it more complex, it can create the failures will be silent and they can be costly, right? Uh, it doesn't always notify that, oh, I mistakenly created like 50 tasks instead of 14 tasks for you. It doesn't do that. uh, it is just like fail and fail silently, which is even more dangerous. So when we use the agents, we need to always be careful that have the second pair of like eyes on what the agent is performing. And then context window limitation, like as the amount of back and forth interaction goes long, it'll be like it might lose the important context of why you're interacting, and it can reduce the reliability. I guess this is our last slide. Yeah.
Yeah, no, I think this is all. And if you have any questions, please send us on the chat because I'm not sure it can solve.
Yeah, sir. Sunny, like are we doing like, can we do interactive Q&A? Like, I mean, we have 5 minutes. It's up to you.
Yes, sir, actually we are running short of time.
Okay.
Yeah, so that's all, Sandeep. If anybody want to connect with us, feel free. We will be happy to resolve any of their issues in writing their first patent, and happy to enable them to accomplish the work.
So I would like to thank Mr. Abhishek Agarwal from Amazon and Mr. Praveen Gupta Sarkar from Meta for their valuable insights towards agentic AI, which also uh, designates one of the tracks of ResGenX AI 2025. Thank you for being with us. Thank you, sir.
Thank you.